Hey guys,
Hey, Nilesh.
how are you guys doing?
Good. How are you?
Good. I just, whenever I see Mark, I see the background, and his background is beautiful. That is something that I would like to have one day. I don't know when, but it needs to be constructed. Apparently, I'm talking about his sunroom. That is so beautiful. Looks really beautiful from here in the camera view, and
Thank you
I
very much.
I need to learn how to build it. He built it himself, which is wow. I yeah, only thing I can do is with my keyboard and mouse. And I have no other tools. I carry some screwdriver, but that's it. No other tools with me. Most people I know actually have lots of tools and they do hand work by themselves. But that's not how I grew up. So I grew up in India where manual labor is cheap. And so if you find something that needs to be done, you just call somebody and they'll do it for you.
Yeah.
So I never learned anything. Literally, I have absolutely no idea about how to fix things, physical things, objects. Virtual, totally no problem. I can fix it if it is soft, as in software. No problem there. But if it comes to physical objects, yeah, not me. But I will learn. And one day I will build my own solarium in the back of this house. One day. Well, having said that, we have 3 more days to go. And we have planned a get together on the 2nd of November. We have a session today, then on 1st and on 3rd. We have a request for specific content. I think John had requested that we specifically talk about and discuss big data architecture. So that is something I want to make sure that I focus on. We have these 12 or 6, so many different, I did not even count, but so many different PDF files that I have put that in a Slack chat channel that you may have accessed already from the last sessions. And so here are the Slack chat PDF files that are available to you. What I would like to go through is these ideas under the hood as to what do they mean. You know, these pictures are primarily, if you think about them, they are marketing material. They're material for people to use Amazon Web Services in their businesses. That's how they are designed as a marketing vehicle. But we don't have to use the marketing aspect of it. What I would rather do is, there are so lots of pieces of nice nuggets of useful information I would like to extract from here and apply that to understanding architecture. These are actually published as what Amazon calls reference architecture, meaning the core idea here is that you use these as a reference as you implement this thing in the Amazon's cloud, that you use this as a reference diagram. That's the core concept behind these illustrations that are, by the way, done very beautifully. I should say that they're done very nicely. They apply to a variety of situations in businesses. And what I'm doing is sharing my screen before I forget, because I'm actually illustrating and not sharing my screen, which is silly. And I do this almost every single day. I just forget, and that is silly. So these are the things that I'm talking about. So for a given application of some sorts, this is how you would go about using them in terms of implementing a given architecture. So it is worthwhile spending some time in understanding what these big companies think of. And by the way, similar charts are available from Microsoft also. You can actually visit the Amazon Center as well as the Microsoft Center for Architecture. So let's see them. What I'm talking about is this AWS Architecture Center. And there is this website here that has a ton of resource that describes a variety of use case of different applications as to how can you take a given type of application typically commonly used in business, and you take them and apply them in the context of cloud. So that like this is the Amazon's work, and here is your Azure Architecture Center, which also has done similar work. But again, the focus of these two websites is primarily helping people understand how do we take a variety of application scenarios? Like, here are lots of things like application services, identity management, hybrid networks, network DMZ, virtual machine workloads in Linux, virtual machine workloads in Windows, and SAP implementation, SharePoint servers. So these are a variety of use case scenarios implemented in the Microsoft Cloud. This is how you would do it. Now, this is a never-ending discussion. We can keep discussing these things until cows come home, as some people say. I don't, because what I want to do is stay focused on a couple of key things of interest. So that's what I have identified, these elements that I have shown in Slack chat that I want to begin discussing with. And I would like the discussion stay focused on use case, understanding what does it take to get a complete work, workflow of some kind of work, like batch processing activity for a given company that you have to do and get it done. So you don't specifically have to use the Amazon services for that, but I will give you the analogous implementation that you can take to any cloud and apply this. So that's what I have in mind in terms of making sure that you get through the perspective of understanding what these things are, how do we get to applying them. And we'll, of course, discuss the idea that John mentioned that we cover, and that was the discussion on this topic of large data sets, generally known as big data. What does that mean, and how does it apply to what we intend to do? And there are lots of things it's like complete domain knowledge that you can apply in every given domain, that you can go deeper and deeper until you get the thing exactly how you want for your business situation in your company and things like that. But I'll give you an overview level, and of course let you dive deeper and ask more questions interactively. If you find something interesting, you should do that. If you find that you want to drill down deeper in any of these discussions, please ask questions. Having said, let's check whether we are recording. How do I check that? I think you can check faster than I can because I don't see the view that you see.
I see the red dot that says it's
Good.
recording.
Sweet. So red dot means good thing. We are recording. So we should proceed first with this. Maybe I'll just go alphabetical and just spend time in understanding what does that scenario is from a business perspective. Understand what does it take to implement that in a cloud. These examples show Amazon cloud, but that doesn't really matter too much. It is what we focus on is the actual activity that advertisement serving. So this idea that you have here, the core idea here is basically how do you become Google.com or Bing.com or other advertising companies that provide advertisements. From an advertising perspective, let's see what boils down to. What's the business? So I'll first briefly discuss what the business is, and then understand what does it take to implement this. That's what I would like to describe. What is advertising? How does it work? Who are the players? And then understand what tools and things that we need to make sure that it actually works the way we want it to be. So I'll open a new blank sheet of paper, discuss the core idea behind advertising as a business. So typically, advertising has a player. There are multiple players, like this is one player. This player is the person who wants to advertise. They are called the advertiser. Advertiser. I may be wrong in my spellings, but this is the person who is spending money. And then there is this, what I call magazine, or some kind of there are industry terms that are different from what the terms I use, but this is another player. The player is a magazine. That is where you create an ad. This is the ad, and you have to post this ad in the magazine. That shows up here to the reader. So the readers are people like you and me primarily. And so readers basically read these magazines and they see these ads. So that's the primary way of operations. It's very basic to understand. Like you have two players primarily to begin with. There is an advertiser and a magazine where you take the ad and publish it, and then you give them money so that they will actually show the ad to the reader. That's the business. Now, it is difficult for the player to go straight, this advertiser player, to go straight to the magazine or the publication. Let's use another word. So advertiser and publication. That's a better word instead of magazine. Let's call it publication of some sorts. And publication can be something like CNN.com, Fox.com, and all the online publications you can think of where you see advertisements. There are tons and tons of them. I don't need to show you where you can see advertisements. They're everywhere. They are on publications. And these are the publishers that publish their useful content. And then they will blend in ad content in between useful content. And like that. That's the primary business model. They'll embed advertisements alongside useful content so that people who want to read some publication will come and see, and they will get some ads. And of course, they will hate to see the ad and all that. But they will bypass the ad, block the ad, but still get to the useful content because apparently that useful content is very interesting to the reader. Now, the advertiser spends money so that they are also giving the ad to be placed. This ad needs to be placed in this destination and also in this destination and bunch of other destinations across multiple publications. But reaching out to a bunch of different publications like CNN, Fox News, this company, that company, it's a long list, like thousands and thousands of them, maybe more than thousands, millions of them. So it is difficult to reach them for a single advertiser. Really hard to reach all these guys. Really, really difficult. So what do we do? How do we solve it? That's what Google does, actually. So Google comes into play in between these two parties. The people who are spending money, and they're giving an ad. They take the money, take the ad, and then place that in multiple places. So Google does this in multiple publications. There are other companies like Google that do the same thing, like Bing, for example, Yahoo Ads, and there are more. I don't even know the names, but you can search and find out. So that's the business primarily that we are talking about in this illustration. Advertisement serving. The core use case of this implementation is if you are a company that is into business of serving advertisements, what is going on is you are not a CNN magazine. You're not Fox News, although you seem to be serving advertisements. Like if you go to CNN.com and try open up, you might see an ad. So here, this is the publisher or publication. And somewhere here, I see an advertisement. Where do I see an ad? Maybe I don't because I have an ad blocker. So let me remove my blocker and ad block options. How do I disable this? I want to just temporarily disable my ad blocker. So let me go show some ads for you. Extensions, ad blocker disabled. Okay, and now refresh CNN. So you should see some advertisements, which you are pretty sure, I'm pretty sure you've seen them. I just don't see them yet, but here it is. So this paid partner content, this whole section is actually advertisement. This segment, for example, this picture and this refinance rates for October, and this valve replacement and the game changer for Americans, whatever that thing is an advertisement. The compare cards, health grades, lending tree, and all of this, basically the whole segment is the paid partner content, is some kind of an advertisement coming. Here is, so bottom line, what I'm trying to communicate to you is those segments that you look at, say, in a magazine or a publication of, say, CNN, there is this useful content, there is an ad content, and there is some more useful content somewhere. This block of HTML is actually coming from these guys. It is showing up in that location. So let's go see that. Let's go see if it is actually true what I just said. So we'll go and see an ad. Maybe another publication is better. So NY Times. See what comes up. And do I see an ad? No ads. Where do I find an ad?
A lot of times it's when you actually click on an article.
Ah, there it is. I see the ad right there. At Delta keeps climbing. I see that's an ad, right? So if you now look at that, and say inspect, you're looking at that particular segment is coming from some other location. You can see that right there. This image for Delta, keep climbing, is coming from Google. You can see that right there in the image source. And you just hit it, right click and say edit HTML, and you grab copy and take it to a Sublime editor so you can see it bigger. And here it is. You can see that that segment came from Google. How do I know? Because I can see it. It's coming from Google syndication, and here is the ad image source. I can just copy that segment, go here, open it up, and I see Delta. So that segment of Delta keep climbing picture is coming from the Google ad network right in New York Times at the top level. This segment. You can see that in the HTML portion that I right-clicked and inspected. So what you're looking at now is maybe this is another Delta's ad. This segment is similar. You can copy the image address and see that it is Google as well. And here is the other link. See Google syndication. So this is what you're really doing, is sending a picture over to the publication like New York Times or CNN, where the ad is getting embedded. And therefore, since they are embedding your advertisement, Google will pay them some money. And this guy will pay them a lot more money. So a lot more money goes to Google. Some money trickles down to the publication. Not too much money, but some money. There is a rate at which they will transact. The transaction rates are typically how many times, rather, there are two commonly used metrics: cost per million impression or 1,000 impressions, CPM, cost per 1,000 impressions. How many cents would you like to spend? Like, I want to send 50 cents for 1,000 impressions on this page, like this page. So this is just one impression. If I refresh it, that's a second impression. So this time, second time, it may again get Delta, but maybe third time it will be different. And that's an impression that Delta is actually purchasing from Google to post on New York Times. So 3 different parties. So this is one metric, that you spend 50 cents per 1,000 impression. Another metric that some people like to use, which I actually like. If I advertise, I would use this metric, cost per click metric. So I am willing to spend something like $1 for a click. The click basically boils down to me as a user clicking on the Delta link like that. So it takes me to Delta. So this is like Delta getting the visitor from New York Times over to Delta Airlines website because of a click that happened. So I just wasted Delta's money, by the way. I just did that. I wasted Delta's dollar by clicking on New York Times advertisement. So that's what happened, is New York Times spent, I'm just making this dollar number. New York Times spent $1. They gave it to Google, and Google placed this advertisement, which I clicked. So that was the business transaction. So that's what the business of advertising essentially is. Now, back in this picture. Let's see what that thing, how does that discussion translate to this picture, and how will you go about implementing this idea of advertisement serving? So let's go see that. Here, we are looking at ad servers. These ad servers are actually serving the advertisements. So that segment of code that you saw here, which is coming from Google, this segment is actually implemented somewhere in the ad server called googlesyndication.com, or rather tpc.googlesyndication.com. That's the ad server's name, or the DNS name for that server. And so this elastic load balancing endpoint, which is what a link to the ad resource, is what the visitor is going to see. The visitor actually is seeing the thing coming from some other location, but it is actually served by, or rather controlled by, the ad server. So this CloudFront endpoint, which is a content delivery network, is actually sending the advertisement in form of an image, in form of a video, sometimes in form of a text. Google is very, very famous in showing you advertisements in text. So if you say, search for something, and I search Cloud Genius, so I see that I see some advertisements. Maybe I don't. Let's see something else. I'll search something else. Let's say, what do I want? Ice cream. Yeah. So let's see some ads. No ads. I don't see any ads. What's going on? Yeah, but you've seen text ads, right? What I'm talking about is a text ad that I have seen. You have seen. So there are 3 types of typically audio, video, image, and text. So those advertisement content is actually coming to you from some kind of a content delivery network, which is controlled by your ad servers. And that activity behavior is actually a big business. The behavior of activity of this user, the visitor that is visiting the content coming from, it appears to come from something like New York Times, but actually it is not coming from New York Times. It is coming from a third party, like Google in this example, like Delta here. And now here's a video ad right there. See that video ad? So they've embedded a video right in there, just like this. So this video advertisement content showed up because apparently they tracked me and I clicked on their image link. They seem to be believing that Nilesh, or they don't even know me yet, but this person, this visitor is actually interested in Delta. So let's show them some more video content so that they might be enticed to play the video and then maybe learn more, to go to delta.com and maybe eventually buy a ticket. But I have none of those intentions, so I'll skip. However, if you now examine the black colored portion, which is the ad serving infrastructure here, the black portions as opposed to the light colored, white colored portions are the click-through infrastructure. So, if you divide this line something like this, in this half, and so on that side is your ad serving infrastructure, and on this side is your click-through infrastructure. So when you click through something, so like this visitor clicked on the ad, clicked on the video, clicked on the image, something that they saw that they found interesting, they apparently clicked. Like I click on the learn more button. The very next action gets transitioned from the black side of the things to the white side of things. What does that mean? What does that do? Let's go see and understand what does that actually do from a practical perspective. So imagine if this ad server, through this collection of cloud content delivery network, CDN, this visitor is able to see an ad and they click. The moment they click on an image or a video or some other text or something else, there is basically a hyperlink built in. So if you now look at that link again and go to Delta and you right click, and instead of say copying image address, if you say copy link address and copy that and bring it here, you will see something different, not the image, but actually it goes to a different site. This is your DoubleClick website. DoubleClick.net is a advertising agency, where actually I should say advertising intermediary. That's the right way to see it. It's the company that is in between the person who is buying the advertisements and the publication who is actually serving the advertisement. This intermediary is what DoubleClick is. DoubleClick, I think Google acquired them. So Google owns DoubleClick. That's what you're looking at here in this Google Ads, DoubleClick.net, and then some tracking methods. So here is one metric. Actually, most of it is encrypted, so you don't even see it, but there are a couple of them. And there is a ad URL, which is the next URL we want to jump to. And so you can see that it actually jumps through and through to this destination URL after they click, and lots of things are encrypted, so you don't see it. But parts of it, you can understand that there is this website called ad.doubleclick.net and a Google Ads doubleclick.net. Those things are actually tracking your clicks. And those clicks are basically sent over to a backend. So this is where the click-through request goes through. So it is also another load balancer. You have click-through servers. These servers will actually respond to the click. But before you send that person off, what you don't see here, what you do not see is delta.com, what you would expect to see actually. if I go to say here and say right click and say copy link address, you would expect to see that if I hit on this link, it goes to delta.com, but not really. Not really. It eventually goes there. But before that, before it jumps, it is going through this entire click-through infrastructure. And that click-through infrastructure needs to be really quick, really, really fast. You can see that here. So I can go right-click on an ad, copy the link address, and go to the command line. And here in the command line, I'll say, curl, show me where this goes to. And so it's a parsing error, so I think I'll do it again. Curl, show me where this goes to. And it says it is going to go to a 302 redirect. So this is a 302 redirect found, which means you don't go actually here, you go to some other place. And it goes to what location? It goes to this location. That's where you should be redirected to. So we copy that new address location, which is the redirect location. It also has set a cookie on our machine, by the way, right there. You can see the cookie. This cookie will stick and will actually monitor and track your future activity on your web browser, because it is going to be persisting unless you clean out your cookies. So that's how people, you may have noticed this idea of, if you express or you search for something, or you want to buy something, or you happen to click on a link of some sorts, other sites apparently get this idea that you are interested in that thing, and they start serving you more ads of the same type. For example, if I want to buy a car, let's say I search for something like a Toyota or a Ford or some kind of car, I want to search for it, then apparently these search engines and all the companies just generally figure out that I am interested in purchasing a Ford car or a Toyota car. So then all the ads that they will show me going forward from that point in time will be about Toyota or Ford, because that's what I apparently searched. And I'm comparing these two cars because it seems like I'm interested in buying them. So how do they figure that out? That's the business of actually correctly serving ads to the right kind of person, because you don't want to waste your money, your dollar, in your marketing dollar on the wrong person. So you have to very narrowly target and get the right persons to get to your product so that you can get the person on delta.com website. Apparently now they have figured out that I am interested in buying a ticket for some reason. So if you now go curl this link, you will see where it takes us. So curl-I, and I think I should put a quote around it. And it shows me that it is another redirect. So this is another redirect, 302. And it says the location should go to delta.com. And now it goes to delta.com as a consequence of 2 hops. So those 2 hops under the hood, what they have done is set a bunch of cookies on our browser. And also what they have done is, back here, they have tracked the behavior of this IP address. And they will associate that tracking, that click tracking, through other activity that this person may have done on this advertising infrastructure. They will accumulate all those impression requests, or rather I should say click requests, through their click-through servers, and store that data, click-through logs of click-through, like these logs, into a bucket of some sorts. That's where they're collecting aggregate statistics globally on all the people who are clicking on ads worldwide, on all the publications, wherever this particular company is serving the ad. So this is like your Google, or like your Yahoo or Bing ads, or all of those ad providers. That's the idea here under the hood, is you're basically collecting these click-throughs and you keeping them in a bucket to begin with. And then you go this is, by the way, a ton of data. This is what, I would generally classify this as big data. Generally, because it is actually big, but that doesn't actually be defined. I'll define big data for you as to what it means, and we'll discuss that. But this is an example of big data. A big data is something that doesn't fit on one big box, so it needs multiple boxes. And I'll talk more about what that means and in terms of understanding what do I do now with this ton of data that I'm keep accumulating here, and then my buckets are getting flooded, and there are so many things that keep coming in because people are clicking, people worldwide. There are advertisers, there are people like publications, and then these guys seem to advertise, and then users seem to be just interested in clicking through, and I'm generating a lot of click data. Of course, in the process, I am sending these advertisers, sending these users. So there is a user person, there is a publication, and there is an advertiser. And these companies like Google, for example, are in the middle. And so this user hits the publication, they hit on an ad, they click on this ad, and then they immediately get jumped to this advertiser's website, like delta.com, for example. But in the process, before they jump, they actually don't jump directly. They jump through Google and then go to Delta. And so that's the Delta is the advertiser in this example. Publication is NY Times. And I am the user, and Google is the company that is making most of the money because these guys pay them a lot and these guys get a trickle. So that's the business scenario. Now, in terms of understanding what constitutes big data, because that's the next idea right here in this picture, is actually big data processing. So if you now look at that picture again, this is elastic MapReduce. And these are spot instances here that will grow and shrink. These are yellow, and the bottom basically means that it is a auto scaling setup. This yellow pattern, the bottom, basically shows you that it is automatically scaling, going big and small as needed. So the idea of this ton of data accumulating, you need to just do something with the data. You cannot just make it sit in a bucket and do nothing with it. Just making the data sit in a bucket and doing nothing is useless. So you have to do something with the data. What would you like to do? And how would you make use of it is what the processing of big data comes into play. So before we jump into this discussion, which is Elastic MapReduce, is a service available from Amazon, which is EMR service. EMR is this service from Amazon, which is implemented running a bunch of different open source products. Basically, one of the biggest ones that is under the hood is Hadoop, which is this open source product called Hadoop from Apache. That's the product primarily that people talk about when they talk about big data. We'll discuss this product briefly, but this product is not the original creation. The original creation comes from Dean and Ghemawat. These guys, two people in 2004, actually wrote down a paper. And that is this paper in ACM Publications. You can see that right there. This is the publication that you can actually download and read. It is freely available, which defines the concept of map and reduce, which is simplified data processing on very large clusters. That's what these two guys, Jeffrey and Sanjay, both from Google, wrote this white paper, published it, and it is now publicly available since 2004. So looking at that paper alone, what this guy did, which is the creator of Hadoop, which is Hadoop is the implementation of reverse engineering of that white paper. So Google never actually published the source or the actual thing that they do in terms of MapReduce, the concept. And this concept is implemented in this Hadoop product. And this Hadoop product is created by, what's his name? Hadoop creator. What's his name? Doug Cutting. This guy created it based on this paper that you're looking at. So let me paste these papers for you, or at least the names, so you can search them. So Jeffrey Dean and Sanjay Ghemawat are the two guys that I am referring to right now. And this is the person who created Hadoop as an implementation based on this paper. Now, this paper is the foundation of Google's search engine, by the way. So what Google does in terms of searching, the origins of search engine actually comes from this paper, this write-up that you see. It is a good write-up, difficult to comprehend. Of course, it is complex, but I'll attempt to simplify it for you in terms of understanding what this thing boils down to. And this is Doug. He used to be a Yahoo employee. I think he works for his own company now, or maybe he joined the Apache Foundation or something like that. I don't know what he does, but he and another person are the co-founders of Hadoop. And so you can read more about them. However, let's continue forward. So what I want to discuss is this idea of MapReduce. What does it do? So you know that we are dealing with a ton of data. That's something you should remember. Now, having understood that point, let us see what we can understand in terms of, if we are getting so much data from people and then we are storing it in a bucket in some kind of a storage solution like S3, for example, and we want to process it. If you want to process this data, you cannot really, it is so much data coming in, is that you cannot really process by the biggest machine that you can buy, biggest computer you can buy. You cannot really finish processing the data that came in the last 24 hours. It will take you a lot more time than 24 hours to finish just the data that came in 24 hours. Basically, you cannot finish the work. Even if you buy the biggest, most expensive computer that you cannot process finishing, because the incoming rate, input or incoming throughput is way bigger than what you can process. So that is the problem. Too much data coming at you. So how do you solve it? That's what the first step towards solving this problem is to put a cluster. A cluster basically means more than one machine. Like we discussed before, we have worker 0, worker 1, worker 2, like that. These machines together will operate like a cluster. And under the hood, there will be also some leaders or managers, leader 0, leader 1, leader 2, like that. And or maybe manager 0, manager 1. So that the naming is not important. But these machines together will actually formulate and do a bunch of things to make this work, the inbound coming data that you have, to process the data and finish it before new data arrives. And so that is the one critical thing needed is a cluster of machines. And this cluster will grow and shrink depending on the need of the business, or depending on how much data you need, it will grow and shrink. The next idea that we need to be able to do is to understand that there is so much data that accumulates every single day that it is difficult to actually move the data. So moving data becomes difficult because you have too much. Moving data is difficult. So what do you do to solve this problem? Because it is like, we are talking about petabytes of data coming in from multiple sources, and then we have it, but we want to process it. And it is, if you, in a classic situation, you have some computers here, 3 of them, for example, and you have a disk here and a disk here and a disk here, like that. And you want to take your data from the bucket. So you have this S3 bucket, you take some data, put it here, and take some data, put it here, and have that data processed. That is possible. But it is so large that moving data becomes really cumbersome. And so you have to solve this problem also when the data is big. How do you solve this problem? You solve it simply by moving the CPU. This machine will go to the data and operate it right there. Or rather, there is this idea of S3 doesn't actually illustrate that point. So I'll not use the S3 example, but the way this was solved, this is solved, is actually implementation of a file system called HDFS, Hadoop file system. And what this file system does is, it's basically, think of it as a bunch of machines. Each one of them have a disk, and they will all together store a common file system. That file system, which is shared across multiple machines, is what HDFS is. And what it does, it So let's say you have a new item, let's say some picture or some text file or some content, basically some content that comes on. And this is just one of the items that I'm talking about that is coming into the bucket, into the sources, into the original input sources, like coming in from here. We are getting basically tons of clicks. Most of them are logs, click logs. That's what these, in this example, that's what they are. They're not really pictures, but they are basically log files. So let's not talk about pictures, but instead say log. Really gigantic logs that you have, and you're collecting them, and it is going to be available. So let's say log number 1. This log, the first log I will store it in 3 different places: L1, L1, L1. And of course, I have more machines, and they all look like this, just like that, any number of that I have. But in this file system that I'm doing, I'm storing this L1 log data in at least 3 places, 3 disks, storing them, 3 distinctly different disks at the same time. So it is very, very redundant, because you have to make it redundant because disks are cheap and you can just afford to spend a lot of money on disks because you need to store data. So you better store it in a system which is going to persist and is going to keep track of. So that's the core idea underneath HDFS. So in a typical cluster that will look something like this thing, each of these computers will have a storage, and these together will form an HDFS system. So in your HDFS implementation, you will have something like a level of redundancy, how many times you want to store a particular file. So L1.log, this log file that I will store it in 3 different computers. And L2, again, 3 different computers. L3, 3 different computers. And that's how I'm spreading them multiple locations. So if you look at a given situation, if you have like so many different disks, and here's a matrix of all the machines that you have L1 here, you have L1 here, and maybe L1 here. And you have L2 here, L2 here, and L2 here. And like that. Third log sitting here. And so that's the layout of a file system from a redundancy perspective that you create in HDFS. And then you have these manager machines, M0, M1, M2, like that. Those managers will keep track of these workers. So we have these many workers which are in a cluster, and managers will actually keep track of where each file actually is. So we have L2 here, L2, L2. Okay, I know where they are. So now if I want to send some compute workload, or rather, I should say, I began discussing this idea of moving data is difficult, right? And so what I'm doing is I would rather move my CPU, move execution to where the data is. Move execution to where the data actually is sitting. What does that mean? It means in this picture, if I want to compute and do some computation, do some processing on the data L1, and each of these square boxes are actually computers in the Hadoop cluster. So if I want to run some process and I need to process the L1 log, what I will do is ask this machine to work and this machine to do nothing right now. These 2 guys will do nothing. But I know that if I want to work on L1, I will start my code execution on this box, not here, not here, but just go send it here and make it run right there, so that I don't have to move the log file itself. I just send my code to execute on that box right here. So please run my code right in that box, and when it is done, you report back to the manager so that we know that the processing for L1 is done. Okay, great. Now, if I want to process L2, I will arbitrarily select my code to go process wherever L2 is sitting. And so I start my process here and I attempt to finish the process, but then for some reason this machine dies. And so that's okay because I have 2 more copies sitting here. I can always assign that work of processing L2 to one of these 2 guys. And in the meanwhile, I'll replace the dead machine because I have copies. So that's the core idea behind HDFS implementation under the hood. The file system is highly resilient. You just store your data right on the disk and you don't move it around unless some machine dies. In that case, you copy. And then you have the L2 backup again. The disk becomes available. The machine itself is ready for processing. And if you need some processing, and by the way, this machine L2 can also store L4, 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 and L17, or any number of storage. Like it doesn't even have to store all these guys. The L17 can sit here. So this allocation of where the particular log is kept in which 3 different machines is decided by these guys. They decide where the actual data sits. They allocate work. So the code execution for a particular type of processing will happen on the box where the data belongs, as opposed to the other model, which is typically very commonly understood, is my CPU is here and I have some disk here. So if I want to process something, I just get the data down, process it, and then put my data back. And instead of this model, what we are doing in this case is we just run the code wherever the data is, as opposed to moving the data towards the code or towards the CPU. We just use the local CPU, run it right there. That's the core idea behind Hadoop implementation. And that's what this picture is attempting to illustrate. This MapReduce cluster exactly behaves what I described to you. You can go to Amazon's website, and almost every cloud provider will give you a HDFS solution. And it'll let you implement Hadoop in your cloud example. Basically, this software, which it doesn't run alone, but it has these components that I'm talking about. There is a Hadoop common component. There is a HDFS component. There is a resource manager component called Yarn. Yarn is yet another yet another resource something. I don't know what the full form is, but that's what Yarn is. And then there are other, this is the actual Hadoop MapReduce algorithm, which is a parallel processing for large data set algorithm that is described in that paper that I mentioned. And that is what is implemented in this EMR service, which is available from Amazon. And that's what they are illustrating in this picture, is to use the EMR service. Now, let's think about what that processing will actually entail. So we have the data, we have processing engines running, and we have a place to do something. But what would you do with the data that you collect? So log files get collected, they are sitting in the bucket, and you have, by the way, in case of Amazon's implementation, this MapReduce engine will operate directly on the buckets. So the bucket becomes accessible to EMR clusters readily. So you don't have to move your data around again. You don't have to copy the data from here to the machines and like that. These machines are able to directly operate on, this is Amazon specific detail. They are able to operate directly on the bucket without having to asking you to move the data away from the bucket to the EMR cluster. That is not necessary. And that is the design that Amazon has done. Same design Google has done is you just dump it in the Google storage and you run a cluster. They will do the processing for you without having to move the data. If you are implementing your own cluster, you have to basically not use these kind of storage solutions, but instead you use HDFS. So the example I think we saw in the last session that I ran about 3 or 4 months ago, we had a person from Expedia. He runs the data center for them. And he is running, I think, about 8 petabytes of data in their Hadoop cluster, which is locally located inside the company. And that's a massive, massive data cluster. And they were contemplating at one time to migrate it to the cloud, but they decided not to because it doesn't make sense, because it is difficult to move the data. And also, if you move it one time, okay, for some reason, if you're able to, which you can, but then you are stuck here, but you cannot go anywhere else or any other location because moving is hard. And that's the problem of big data is, it's there and you don't want to get rid of it because of the fact that I think I mentioned in the other example which I gave you about SQL versus NoSQL setup. If you remember, I gave you this example of schema at the time of writing is necessary, whereas here, schema is not necessary. Not necessary at writing. At the time of saving data, you don't need to have a schema. You just save as is. And then when you want to read, you apply a schema at reading time. That's the difference. And this is the model in Hadoop. The same NoSQL model that you just save everything. You got a log file, you dump it. Anything that you're collecting here, you just dump it. And not in this one, this illustration. By the way, this is also a Hadoop cluster. The other illustration, which is this one. You have, and whatever you get, you just dump it in the repository. And you don't waste time in filtering or deleting stuff. For example, where did that picture go that I was drawing here? So nothing needs to be wasted. In fact, the creator of a company which implements Hadoop, one of the companies is called Cloudera. And their founder describes the idea of this SQL versus NoSQL in a different fashion. He says, if you have, say, for example, a home in Seattle and another home in somewhere in, outside in like a farmhouse in remote places like Snohomish. And you are going to be, Seattle is an apartment, and you have a small kitchen. And here you have a full yard. And so you are a professional chef. And now you want to make a pig roast, or rather cook pig. The way you can do a pig roast is not really completely possible in a small kitchen in the apartment in Seattle, because you have to cut the pig down and remove certain parts that do not fit the schema, because you are saving that pig only the portions that you can actually consume. You have to get rid of the portions of the pig that are not going to fit in your kitchen. Some body parts that you are difficult to manage in a setup which is like an urban area and a small kitchen. You may not be able to fit a complete pig roast and smoke the whole thing. Not possible. You can very easily roast the whole pig in your yard in Snohomish without causing trouble. That pig roast is kind of difficult to implement in a kitchen because there is constraint. The constraint is you have to have a schema in which you can fit certain things coming out of the pig as you cut and chop, and those portions some portions need to be discarded. For example, the tail. I'm just making it up. I don't know if you eat tail or not, but the tail has to be discarded. Maybe the head gets discarded. The head and tail get discarded as you go to the kitchen, but not here. You can keep the whole pig. So that's the idea behind NoSQL and SQL, or in Hadoop, you just store the whole pig, because this gives you another benefit which is not super apparent, which is gives you the ability to go back in time and find out if you are missing something in your regular way. So in the regular SQL way of analysis, if you want to get to the head and tail of the pig, it's gone. You deleted it and you threw it away. Whereas here, you can always go back and find how was the head, how was the tail, and can you make something out of it. So you always have the option to go back and reanalyze. And that is not possible in classic SQL style databases. But here in Hadoop, you can. You have a ton of storage available. You just dump whatever you get, just save it right there. And that's the usage model behind this Hadoop illustration. So what you're doing is any type of click-through activity you just get, you just dump it and you process it. The processing basically boils down to identifying and applying all the methods that you can apply with this visitor and visitors similar to that visitor, and identifying a pattern as to what kinds of ads would I be serving these guys next. That's what it boils down to. What should I do next from an advertising company perspective? What should I be serving next to this user? And it is individually targeted. So that if you now, I'm not sure if how many of you have seen some kind of an ad interface to companies like Google or Bing or those guys. Let me show you something. Ads. Sorry?
Facebook is the one that does the most mining, I find.
Yes, everybody does. And so Facebook is strictly focused on advertising on its own platform. So the idea of Facebook is it is not your classic ad intermediary. So Facebook, what Facebook does is here's an advertiser. So that wants to spend money and they give it to Facebook. And what Facebook does is takes the money and shows it in Facebook. It shows it right here, right? If you go to Facebook, you will see the ads. They don't typically serve your advertisements to publications outside, right? So whereas in case of the other example.
Well, they must have some sort of partnership going on, because I'll do a Google search, and then later on in the evening, I'll get an ad from Facebook.
Yes, they do it all the time. So the core idea is basically you have an ad company, you have a publication of some sorts outside, and you want to advertise in that publication. You get to select and you get to tell Google, hey, Google, I would like to publish my ad in these publications and not in these ones. You can actually select and target, and don't go here, but go here. And this is not the model of Facebook. Facebook says, I am the publication. I'm also the Google or the intermediary. I'll do both for you. So they keep the whole thing. They keep all of your money, and they track. They track using what is known as a tracking pixel. Let me see if I can bring up the tracking pixel for you, because I have practiced it. I never put it to use until now, but I might use it. So let me show you if I have it. Are you a publisher? No, I'm not. Let me start. Let me just log in. Let's see if I logged in. No. Gmail.com. And I'll show you the advertising portal. So ads.google. Or rather, it's called AdWords. Aha, AdWords. I forgot. It's called AdWords.com. So there are two websites from Google. One is for AdWords and the other one is called Ads. So the ads.google.com is where you, like a CNN or a Times or a New York Times, will go and log in on this Google Ads website. And when you take these ads from Google, place it on your website, you get paid a little bit of money. So you can actually make money like this if you go to Google Ads site. But that's not what I'm talking about. From a advertiser perspective, you are not a publisher. You are a advertiser. So you can get your ad on Google today. You basically sign in and you log in, and then you get to the portal. The portal will show you exactly what I'm describing right now. Is if I want to place an ad. So you'll see an ad from Cloud Genius coming up. Nothing is running right now, but you should be able to see an ad right here. So in this display group, I should be able to see an ad that looks like preview. And so here is an ad that is going to show up like Cloud Genius ad. So it's a very simple ad. So this is the advertisement I was playing around with, and I actually haven't actually used it, but this is what will show in the browser if you visit CNN or Times of India or New York Times or wherever I decide which publication should go. So this is an advertisement that I don't know if you have seen it or not. Even I don't remember seeing it anywhere, because I don't see it, because I don't advertise. But I at least tried to understand what these tools are. So this is the ad which I placed, or rather I can place, I should say, and I can decide which display networks I want to go to. I can decide how much amount of money I want to spend on. So here's my maximum cost per click, $7. Wow, that's a lot of money. On every click, I'd go down by $7. That is too much. But that's what I was toying around with. Is I can edit this number and say, maybe not $7, maybe $2, or not 200, but save it. So that's my change. I can just modify these numbers. Similarly, I can also decide where do I want to target. I can very carefully target my audience based on certain characteristics and certain keywords. For example, here is the idea of computers and security and training and certification. Show this ad to people who are interested in that topic, and show it to people who visit my website or in the past have visited my website, and then run. Basically, this is a unique thing that only is available to people who have placed a tracking pixel. So that's is called remarketing. This is something that you need to understand, is how people track and get inside your head in terms of understanding what you really are thinking. So the core idea behind this idea of what is called finding out what's in the mind of this person, what is that person thinking, you can read that based on their activity. This activity is being tracked through a tracking pixel, and activity tracking can include, like, where are they clicking on, what are they seeing, what are they searching. So these activities that you look at, that you track them. And how do you track them? You put in a tracking pixel. Tracking pixel gets placed in a website that you run for a business. So this is the user. Now, if you're a company that wants to sell a product, you need to get a tracking pixel and place it on your website. And that way you can associate a collection of those users that have visited your company's website, and then use Google's help in understanding this click behavior, search behavior, and associate that set of users as the people who may have seen your website at least once, because you basically place a cookie on their website, on their browser, and then let Google manage the tracking activity, the behavioral activity that you are looking at in this illustration. That's what they're really keeping track of in the data that they accumulate in this picture, click-throughs. And that data is stored and analyzed here. Back in our discussion, this pixel will look something like this. Let's see, Google Pixel, where is that? GitHub. I think I may be able to show you my pixel. Let me log in first. I'm not sure how many, if you have seen a pixel before or not, I don't know. Are you interested? Let me know. I don't want to waste time. If you're interested in seeing how the pixel looks like, maybe it's helpful. But if not, just stop me. I'll move forward. There is so much to cover that I don't have to. I can skip. Just tell me to skip if you don't want me to go that direction. I am going to find out my pixel and tell you how to implement it, and then take that next idea about targeting. The core idea behind pixel is to target a set of users. So let me log in first. Here, log in. No, where is my token? Hello, token. Come on. Where is my token? I don't have a token. What? There it is. So the token is here. And this is my token. And so I paste it. So now you should be able to see some internal code where I will show you the pixel. Oh, no, it's not here. I think I moved it. I forgot about it. It's called Tag Manager. So there it is, I think. Tag Manager. Where is the Google Tag Manager? So Google has a new method of storing all these and centralizing in one place. That's called GTM. But where is that? It's here, GT, Google Tag Manager. And so in this location, I think it's easier to see it this way. So Google Tag Manager has a capability to centralize all these tracking pixels for website owners, business owners. And so this solution is called Tag Management Solution. And here it is where I sign in that you should be able to see my tags. The tags are basically pixels, or other people call it other things, but here is the CloudGenius live version, and I have a bunch of pixels here. You can see some of them. This is your Google and Facebook, and let's go see one by one. So first one is remarketing. I think that's the most relevant one. So here is a pixel that Google will place this particular conversion ID as a remarketing target that I will basically place it on every page view. So that's what I'm doing, is on every page view that is anybody who's visiting the website, Google will know that that person is interested in CloudGenius website. And that's how Google will track that particular user who is visiting. And then they will allow me to spend money on Google's ads if I go that route, to let me spend money on their advertisement serving service, so that they can target the appropriate user. This idea of remarketing for AdWords is a placement of a JavaScript, basically. That is what I want to see where the JavaScript is. Maybe it is in the admin section. And here is the tag manager. So this is the tag that I place. So if you now see here, what I'm doing is the tag that I am placing is this portion. I am placing a GTM tag right there. And this tag is unique to me and my account. And that is how Google is actually tracking. You can actually see this tag in CloudGenius website on the back end. So there is tagging and activity tracking already implemented, but then I don't advertise, or I should say I have not yet advertised. And so therefore you don't see any ads, but I am tracking using this Google Tag Manager method. In this same Tag Manager tool, there are a bunch of other tags that I have placed that include other services. For example, where is the workspace and the view of all these things? There should be tags. Yeah, I think here. This is the aggregate list. So there's a conversion tracking code. There is a remarketing code. There is a LinkedIn Insight. There is a pixel-based custom code and a universal analytics code, Google Analytics universal analytics code. So these are the codes that I'm using. Primarily, if you look at LinkedIn Insight, this is the partner ID from LinkedIn. And what LinkedIn does is the same exact thing like Google does, except this is for LinkedIn ads. So if you go to LinkedIn, and you will see some ads in here, and you might see occasionally, like here, you see Zerion or whatever that company is, Zerion. They are learn how electric co-ops are saving something. So this is an ad promoted that came into my feed, but that came in because this company seems to believe that I'm interested in electrical operations for some reason. So they just show me this electrical operations co-ops. However, the idea is by placing that particular tag in LinkedIn tag in my tag manager collection. So this is a collection of all the tags that I'm currently apparently interested in, or I should say I was interested in 3 months ago. So they have accumulated these tags in a tag manager, and I put the tag manager code like I showed you briefly here is what you will see in the back end of the CloudGenius website. This JavaScript will be embedded, which allows Google to collect all those 5 or so tags that you see here, these 5, and allow those companies to track user behavior for me. So when I accumulate that data over a period of time, I can go back to Google and say, or maybe LinkedIn and say, hey, LinkedIn, can you advertise for me? And that's what these guys will do. So if you now focus on this all visitor based on interest and remarketing only, it lets me get to a list of all the visitors. Now, who are the visitors? I don't know, but I know that they are the ones that have visited my website. That's how I know. So they know that this company exists and there is something to do about them. Like there may be some interest for some reason they may have visited the website. So I call them all visitors. So that's my simple method of thinking about that user target. So this is my target audience from an advertising perspective, those who have at least visited the Cloud Genius website once. So I just place a cookie on there. The cookie is the remarketing cookie that you saw in the JavaScript. And now I get to select my ad. And in that ad, I can go and select a particular, this campaign is currently paused, but I can basically go and identify that you run it. So as soon as I say, right, there's some button to run it, I think enabled. Maybe I'm not super familiar with this UI, but there is a place to actually, maybe it's here, enable. As soon as I enable this, they should start showing this ad to a collection of publications to the people who have visited Cloud Genius website at least once and have not cleaned the cookies yet. That's, I think I should tell you, if you clean the cookie, everything is lost. But if you then sign on to Google again, then they will know that it's you. So they will associate that cookie, the previously stored cookie, with your login. And then you are again back in the lock. They keep tracking you. They keep tracking you because they know that I will come and spend money at some point. And that's what I might do if I click the enable button. Because if I enable, then I am targeting people who are visiting Cloud Genius website and visiting CNN, New York Times, or just any publication wherever Google runs their ads. And that's how I can go and reach out to people and show them this advertisement whenever I want to run the next Cloud Bootcamp. Now that I have never actually found it useful. I don't find advertisements work. But that's just my way of thinking. Maybe it will work. Maybe it actually works. But I don't believe it yet, that advertisement actually works in helping people understand what we do and making them willingly spend thousands and thousands of dollars. It doesn't work, honestly. That's my observation. But people don't seem to agree with me and they keep spending money on advertisements, and that's a different story. But that's a different topic altogether. Let's not talk about that. This is the mechanics of showing ads to people. This is what you see. This is what I see. If I want to actually advertise, I can. And what you saw in the illustration is that this is the back end that is needed for a company like Google or Bing or other people to advertise on third-party locations such as New York Times, CNN, Times of other publications. And those advertisements will come like this based on ad servers serving the audience, the visitor, and when they click through, they will keep track of this user behavior and analyze that in your EMR and then store the result of the analysis in the DynamoDB store. And that is this is DynamoDB is just one store, some database. And that's where profiles are stored over these users so that they can then understand and actually serve the right ad to the right person at the right time, at the right publication, and all that rights that you go along. But basically, people like me and you know, and I know, we'll block the ads by using an ad blocker. So you don't even see them. So what's the point? If I don't see the ads, why would anybody see? I don't know anybody who actively clicks on ads. Do you know? I don't think so. I don't think so. So basically ads are bad, but people seem to still advertise, and I might advertise, who knows? Maybe I will. I'm not against it, but I haven't found business benefit of advertising yet. Maybe one day I'll discover. I hear people talk about these things. I don't buy it yet. I hear people talk about that you create a beautiful engine and a car that will run, but then you advertise. Advertise is like gasoline. And you have an engine, you have a car, it will run and make money. But then without this gas, it won't run. That's what people tell me. But I've been running for the last 4 years, no problem. I mean, yeah, I should not say no problem. I do a bunch of other things to make it happen, but it is not ads. Not ads. They don't work for me yet. Okay, enough of ads now. Unless you want to ask some questions, because I'm going to change topics now. So here is the other example, which is about batch processing. I'm just going through the list quickly, and as soon as I can finish the discussion. The batch processing is anything that you can do which is not critical, that it can wait. It can be done in batches, that it doesn't have to be done right away. That's the idea here. So if you want something to be handled, this is a very generic case that I cannot apply it to a specific example to help you relate to something that you know, because it is very generic by its nature, batch processing of something. So you basically assign your jobs. This is the end user who wants to process the task that he or she might have. And you will assign those jobs in some kind of a machine that will become your job manager. And that job manager machine will basically ensure that information about the jobs that needs to be done is stored in some databases. And a set of worker nodes will do the job for you. And this machine will be the control machine that will send and control the actual worker nodes, which will get your job done. If there are too many jobs, you will scale it. If there are not many jobs, you will shrink it. And then you will produce the output and store it in a subsequent process that you might have. So the flow of work that you're doing through this job or the batch, you basically, the output of that will go into a queue. This is a simple queuing service queue, or some kind of a queue, which is basically a waiting line of things that you need to be doing next. And so this is the idea of what you do next after this activity number one. Activity number one is finished, that you want to do now activity number two or any subsequent activity. You will then finish this activity first through using these worker nodes and store interim output into a queue. And then you do the second activity, which is chaining, like one after the other. You finish one batch, and then you put in a second batch for this second activity, and then the third activity works on the queue. So the idea will be extended pretty much like this. You have some input queue of things you need to do. So you give it to activity number one, and that activity will be doing that in batches. And at the end of the result, you have another queue. Let's call it the output queue. The output from here and basically becomes an input for these guys. The next one, the next activity you might have. And this is able to also run in batches, and it will produce the output that you can store it in another queue. And basically the same model goes on. You can repeat that as many number of times you need for a work to finish in batch process, in batches of some sort of a work item that you have assigned, that will go through, finish the processing, come out and sit in a queue until this one picks up. And then it will produce the output, and it will sit in a queue until this one picks up, and like that. That's the chain that they're describing here in this illustration, batch processing. It can apply to a generic workload. So basically not very specific in terms of understanding what you have in mind. Next one. And I may have switched it because it's not material discussion. So there is not material meaningful things to discuss. I will just skip. This one is useful for real life situations in your company, like, for example, Boeing or Microsoft. The scenario here is about recovering from disaster. And you have local applications. They're not in the cloud yet, local. So you have an application here. let's say you have Oracle database running in your data center, and you have some application servers running, you have some disks here, some kind of a storage area network. And what you're doing is basically replicating that storage that you have using a storage gateway, which is this device, and a connection to the buckets in the cloud. So that's the established connection you need to have for a storage gateway replication to function. And then you can have a copy of your disks. These guys, basically the disk that you have in your data center, will be replicated over to the cloud that will store these volumes that you might have in your data center. So that's the storage gateway function, which is basically in the background while you are working. By the way, this blue segment is your corporate data center. So it is not in the cloud. It's right with you in your company. You have a database and some application running, and these users, your company employees, they are accessing the internal data center applications, and they're working on a day-to-day basis, and they're happy about doing things. However, now disaster strikes. And when disaster strikes, what happens? Everything goes bad. And when things go bad, what do? You have the whole thing gone. So now what do you do now? This user is frustrated, and this corporate user needs to be helped out. So you need to recover from disaster and make sure this user continues to function with their business. So how do you do that? That's this illustration. They're trying to describe that concept in terms of understanding disaster recovery for local applications. They are running in your database, in your application servers. But what you're doing here in this situation is making sure that you are creating a replica of what you have here in your data center. This is your data center. You're creating the replica of the same thing in the cloud. So you have a recovery database, pretty much similar to what you have, but ideally exactly the same that you have in your data center, the same database that you would run in your cloud. So it's a recovery mode, and that same database, production database, recovery database. So you have basically item by item, one-to-one mapping, you will see them. You have an application server in production in your data center. You have an application server in recovery mode, right in the data center. You have a VPC. So this whole thing is a VPC. And there is a VPC gateway connection, which is this connection. And what you're doing is asking your users, now that we have a disaster going here, so this is not available. So why don't you just go connect? And you get to the same application server that you had here. Same thing showing up here. And it also is able to access the same volumes that you had here, because they are replicated through the storage gateway and the copy is kept right here in the buckets. So you can just restore the data restoration. And by the way, I'm assuming that you have local copies of these PDFs. You can relate to them very easily, but I'm also projecting, so no worries there. And this data restoration will basically restore the disks here and here into exactly the same that you would expect them to be here and here when a disaster strikes. So you want to recover from that. So you want to restore your disks in this location and this location, or get your application functional from the recovery mode to a real functional mode. And you want to also get your database server up and running away from recovery mode into production. And you will now treat this as your production database, this as your production application server, and the disks associated also ready. Once that happens, you will basically change the DNS and say, hey, user, corporate user, would you please go to the cloud instead? Actually, they don't even need to know. They need to be just told that, yes, you can now use the applications. Because what you actually do is change the DNS. And you used to go this direction, now you go this direction. And so you just tell the user, hey, you can go do your business. It's back. It's up and running. We recovered. We had a disaster. The data center went bad. But no worries. You can continue to function. So they will just continue to function like normal. But they will probably notice that the applications are kind of slow a little bit, because it is not local to them. It is away from them in the cloud. So it might be some slowness, some issues will definitely pop up. It is not all nice and like you would expect. There will be issues. Compared to local, nothing beats local. You have to be there to really understand how quick and efficient a local application can be. It's like running a program locally on your server in your company. Nothing beats that, because of latency is really low. But you have a disaster, so you have a workaround as a recovery method. You're basically replicating the exact same design you had in your data center in AVPC, and you can afford to do that if you have money and if you have a way of systematically backing up your disks into the cloud. So here you basically take periodic snapshots of whatever your disks are here and here. You keep track of whatever you're keeping in the disks. You keep the snapshots of those disk images in a storage location. Basically, these snapshots also sit right in the bucket. You have machine images that will take care of your application server specific images. You have those machine images ready, so you can quickly start your application server. If this infrastructure dies for some reason, you can get this application server up and running based on a ready-made image that you keep track of, and you can just restore from that image and have a new machine start up here in recovery mode and have the same thing happen for the Oracle database. They're basically calling out Oracle because that's what this data center seemed to be using. So the same database here, the same application set here, the same disks backed up here, restored to this location. And now you are back in business. That's how you can recover from disaster. I should call out that recovery is different from fault tolerance. I think you know that already, but I'm just calling it out. This discussion was about recovery. That means you have a data center here and you know that this data center is dead. So you then begin your recovery. There will be some downtime. So some downtime because of the recovery process needs some time. And so this begin the recovery, then this whole thing in the cloud context gets set up exactly as you had in your data center. Just same thing replicated, and you begin the recovery and recovery finishes. And between the begin and finish of the recovery, there is some downtime that you have to understand. But the other side of the same thing is having some downtime allows you to save some money because you don't have to keep this thing running all the time. So there is some money saved. Otherwise, if you want to have a fault tolerant discussion, which is also possible, but it is, I think, one of those other charts. We should see some fault tolerance illustrations. Where is that? Yeah, we'll get to that. So let's keep moving. Disaster recovery, we discussed this. Next one is e-commerce website part number 2. So before part 2, we should discuss part number 1. This is part 3. So this is part number 1. Yes. So e-commerce website. So a classic example of an e-commerce website you already know is Amazon.com. We know this already, and it's like one of the famous retailers. So this is your e-commerce website. You have a storefront, you have a login system where you can log in like this and all that good stuff. And you can look at your past purchase and orders and history and all that. So you know this. I don't need to tell you what this thing is. And so that's what the front end is. The web front end. E-commerce web front end is the front end that users see. This is the customer looking at. And so the customer does a DNS query. I mean, the browser will do a DNS query. Customers don't. The browser will look up the name of the company from Route 53. This is your DNS server. You don't have to use this Amazon specific technology. You can use any DNS server. And that customer will then arrive at a point where your website gets rendered. When you visit that DNS name, you will see some assets or some fixed content like pictures and static content showing to you through CloudFront. That is what will primarily you will receive most of the content which is static coming from some kind of a content delivery network. And the dynamic content will be generated by an e-commerce application, which in this example, they are showing that it is running in a Beanstalk. Again, this is Amazon specific technology, terminology, but Beanstalk, as you know already, is nothing but a platform as a service. If you go to console, you know it, you've seen it, I think. It just runs a scalable platform that will scale on your need. So I'm sorry, your customer's need, not your need. So the Beanstalk basically is you select the language. So create a new one. You select your, not this, my first Beanstalk. Let's see. Where is that? By application, by name. Okay, I think I'll delete this. So I'll delete this and maybe just choose a different region. So I'll just choose Oregon. And that's where I think I should see a clean slate. So here I get to select the application that I want to run in Node.js, JavaScript, PHP, Python, whatever language of choice. And then select to create a Python application. And then decide whether I want to use a 3.4 version or 2.7 version of Python. So I have those two choices here. And I can select whatever Python version I want. And I can then decide whether I want auto scaling and load balancing or not. And most likely I want it. So that's what you will have, a Python-based e-commerce front end showing up in here. This is your e-commerce website. That's what it will look like to you from a customer's perspective. It looks like this. You have Nilesh's Amazon, and you've been customer since 1998, and things like that. So what you buy and all that good stuff. So that's what you will see will show up in the e-commerce front end from a user's perspective. So let me erase this. This e-commerce front end that you're looking at, the part number 1, is primarily about product listing, list of products. So I think they have a list of products, product P1, P2, P3, like that. And then there is this shopping cart where you can add a particular item into a cart. Let me show you a simpler example. So a simpler example would be here. The Cloud Seminar is a shopping cart, basically. So if you now look at this item, it is only one item to buy, and you can look at the item. The item is this, and you can buy it and say $445, and you say purchase this. So it puts the item in a shopping cart. This is what the cart looks like. Update the cart and check out the process. So I'm basically running the same thing. What we discussed, I can put in my credit card number and pay to buy this. And so as soon as I buy it, the whole thing becomes accessible. By the way, I told you that I'm going to give you guys free access to this, so don't have to worry about anything. But it is still under construction, so it's not publicly available yet. Once I release it, I will be giving you access. Don't have to worry about spending money. You will get access. Having said, this is a shopping cart. You look at the shopping cart is empty right now, and you can buy the item. The item is this button to join now, and it goes to the same process. You can basically you've seen this flow. The flow of checkout is not new to most people. Have seen it already, so I don't want to spend too much time on this checkout process. The checkout is basically an application of shopping cart where you put in credit card number, login information, password, details, shipping address, physical address, billing address, and then you buy stuff. That's the front end of e-commerce checkout. That's the checkout application that you saw, one simple example and a very, very complex example from Amazon. That's the front end of e-commerce, the checkout portions. But to support that activity, what Amazon is also illustrating here is in this checkout application that they are keeping track of, there is a ability to search your products. There is a product catalog and a product persistent session store so that you can have people's logins preserved. For example, occasionally, if you have seen, some of you actually, let me point out where that issue was. Some of you occasionally notice that when you go to this website and when you log in here, that you were complaining at some point that this login session doesn't persist. So when I log in, it takes me to the back end, but at least in one time, even I saw that problem, is that it is not persisting my login. It will come back to the login screen again. And that is a problem basically because this time it logged in, because this is not persisting my sessions. So this persistent session that I need to create that persistent session by storing a cookie. And if the cookie that I'm storing in the browser is problematic, or if I'm changing my IP address too much, if I'm changing my store location too much. By the way, I have been changing my IP address quite a bit. As you've probably seen me do this. I have migrated my entire website from a single machine to 3 machines in New Jersey, and I have done it again. This time, you see that they are in Seattle, and they are all 4096 MB machines, $20 each, as opposed to 10, 5. So that is a change I made again. So I keep changing this all the time. And this site is where it is running, the Cloud Genius website right now. And I had to make this change because I found that the 10-5-5 combo, which I went to from a $20 machine, was not a good enough good performing solution for you. I think I measured the performance. It sucked, honestly. So I did not like it. I said, I'm going to do it again. So I said 23 machines. That's now I have right now. That's what you're looking at here. And as a consequence, the IP address I've changed. And you might run into login problems because the sessions that are not stored in a persistent fashion than what I would like to have it storing. So although I have the code that works, but it is sometimes causing you trouble because cookies change and you need to clean the cookies. And it can be avoided over time. I will need to find methods to improve this because I cannot ask customers to just generally clean cookies. But I think you guys understand what I'm going through. So that's what the persistent session store is. You also understand this search engine, which is going to search your product catalog. So from Amazon's perspective, you go to Amazon.com. I just have one product in that website, so there's not much. But here you can say, I want to buy an iPad, and it shows you the iPad selection. So that's the search engine right there. That search engine runs in the context of Amazon's cloud search capabilities that is going to search your product catalog and show that to the customer, because they can then select appropriate product, put them in the checkout section, and then check it out. When they check that thing out, then you need to actually deliver on the promise of selling. So if you sell something, like if I buy this iPad, they need to send me this iPad, and that is necessary. Otherwise, there is no business, right? So that's what fulfillment and other activities come into the second and third part of this e-commerce website. And there's one more piece that you need to stay focused on, which is this segment, marketing and recommendation service. This is also a critical aspect for large-scale e-commerce. And that aspect comes along something like this. So let me just show you that. You've seen it before. You pretty much know it, but I want to point it out. It's right here, this section. Customers who bought this item also bought XYZ. Customers who bought the iPad with Wi-Fi 32 GB Space Gray model also bought these items. They also bought a cover, a smart case, or some kind of another type of case, and some clear glass, and God knows what people buy. But this is the recommendation, page number 2. This is recommendation, page number 3. Recommendation, page number 4. And that is the recommendation that this service is generating, marketing and recommendation service. This is basically looking at customer behavior and finding patterns of similarity from past purchases. And that concept is called, it's also a big data analysis technique. There's a name for it. It's called basket analysis. Basket analysis. and Market Basket. That's the name. So it's a modeling technique based on theory. If you buy a certain group of items, you are more or less likely to buy another group of items. That's the market basket analysis method. It is one of the techniques of big data analysis. There are lots of techniques. This is just one that I mentioned, which is coming as a marketing recommendation that you see here. You also see the same thing in Netflix, which is people who saw this movie also like the other movie kind of game. Same thing again, basically marketing recommendation. You find that people who bought this iPad also bought the printer. Maybe. I don't know who uses printer anymore, but apparently there are people who do. So they also bought this landline phone. How nice. So see, that's a broken recommendation. I don't believe it that somebody will buy a landline phone today. But apparently there are people who buy with a 66 rating. Nice. But sometimes these recommendation and algorithms do not work exactly how you would expect, but they are there. And so those three elements that you saw here, the e-commerce application itself, the checkout application, and the marketing recommendations engine, 1, 2, and 3. 3 on this particular sheet. Let's go to the second one. In this second sheet, where is that second one? Here? Well, here? No? Here? Yes. So the second part is the checkout service, which is slightly go in detail about how checkout action is actually implemented. So you get a customer order from the front end, like the customer places an order. You need to make sure that you follow what you would expect from a checkout process. So the checkout application will actually do a bunch of things. For example, if you buy something, they need to send you an email. So that email basically says, yeah, thank you for shopping. Here is the item you bought. Here's the price you paid. Basically give them a receipt. So that email is sent to the customer from a separate system called emailing service, which is in Amazon's case called simple email service. There are tons and tons of examples of how you can send an email. Automated emails go out. For example, a simple email you can receive is password reset emails from this website. So a simple implementation coming from a company called Mailgun. You may have seen that. Let me see. Somebody got logged out. Who is that? Is there anybody, one of you got logged out in Kent? One of you is logged out. If that's the case, I need to unlock you. But apparently I'm getting a notification saying that somebody got logged out.
Logged out of the class or logged out of your website?
No, L-O-C-K, lock. Here.
Oh, because I tried to log into Cloud Genius, the website, and it wouldn't let me in.
It is you. Are you living in Kent?
No.
Oh, it seems like is this your IP address?
Let me look.
Okay, if that's the IP address, you are logged out. I need to disable that lock. But if you're having login troubles, or if you're trying to reset your password too many times or typing a wrong password, that may cause it.
I didn't do that though.
Okay, no worries. But I can always reset. I can override this thing, but I just want you to know that this is a notification email came to me just now saying that, hey, somebody's logged out.
It's not me. That's not me.
Good. If there's anybody else who's logged out, I need to know. If it is not one of you, I don't need to worry about it. So I can deal with it later. Maybe it is somebody bad who's attempting to hack. I don't know. But I don't care. This is an email system that sends an email on behalf of Cloud Genius. It generates automatically. And that's what I'm talking about in this picture, is this email service that sends an order email automatically to the customer. Hey, you bought this. Thank you very much. Here's the item. Here's the purchase price. Here's the delivery date and all that good stuff. So that's a separate system you have to put in place. In addition to that, there are a bunch of other things that needs to happen. You need to store the customer orders and database in a database that is typically visible to you in form of orders placed, and you can see that I am buying a bunch of things. You've seen it already. There are open orders that I buy a yoga mat and buy something, and something goes on and on. Like it's a long list of things that I buy, and most of us buy it. This list is kept preserved in terms of orders that customers have placed in a database. So that's a relational database. You can have it multi-AZ, multiple availability zones in multiple locations, basically. And that data is important to preserve because people will like to have record of what they bought from you. Otherwise, they don't get the warm and fuzzy feeling of a good website. So they need to know what orders they placed in the past. They need to know how much they paid, and they need to be able to return things of that nature. So that item needs to be kept in a database. So they're showing you that you will store that information here in RDS. And that is also a part of your checkout application. Then in addition to that, there will be more process that needs to happen. For example, this idea of a internal to the company scenario. You need to have some kind of a workflow internal to the company that will handle these incoming orders. And those are these worker processes that will also auto scale. And if you have a workflow of some sort that you need to do A, B, and C before you send an item out, that work needs to be happening in your internal company. So you need to define whatever that workflow is and implement that, make decisions around it. Maybe you enable your internal people in your company with mobile devices, and that's their illustration. Now, next is the part number 3 of this idea, so which is this picture. And part number 3, what we are talking about is marketing and recommendations, which I mentioned to you is a big data analysis thing. Basically, you have another MapReduce cluster, which is going to do the market basket analysis. And this market basket analysis basically boils down to these customers. If they add an item in the cart, you show them 10 other items. Hey, the customers who bought this also bought that. Now, how do you magically come up with this idea? You basically do the statistical principle of market basket analysis. Market basket, you should read this. I think I should just paste that link for you. Market basket analysis. It is probability and statistics, by the way. So all of big data is all statistics. If you don't like stats, don't study it. You will hate it. People find it very interesting to talk about big data, but when it comes down to doing the statistical calculations, it gets boring for some people. And another thing I find is people find that big data becomes a interesting topic to them, but the work that people actually do in big data is not actually big data. It is more about cleaning the dirty data to come to the point where you can actually identify the right set of data to deal with. And then comes the idea of market basket analysis or some other analysis. There are hundreds of methods of doing analysis, but that analysis is the interesting part. The most difficult part in big data is not about analysis. It's about cleaning the data, because you have a ton of junk that comes along with data. You have the pig's tail and pig's head that you don't typically eat. You have the pig's feet that you don't eat. And then you have to deal with discarding that data that is not really relevant. So that is the hardest problem in big data, is about data cleaning, not analysis. Analysis is interesting, right? Of course, you apply your brain and apply some math and stats and algorithms and all that. That's the sexy part. The ugly part, unfortunately, is cleaning. That is boring also, really boring. At least I find it really boring, but then it's a necessary evil. So that's what you're looking at here. MB analysis is what will help this customer identify what other things that people might be, or other customers who bought this also bought that. That recommendation is coming along from this separate system that collects behavior of users from the past. So many years, I think about more than 20 years since Amazon is running in business, they have gathered a ton of data of what people buy, when do they buy, what time of day, what season, what year, things of that nature. You know, people of what age group, what profiles, what address locations, what zip codes, how much salary they make, how many kids they have, what age group they belong to. All these detail, not just in the US but worldwide, and that detail is available to them. And they will store that, of course, in a big storage and analyze, specifically in this context, apply the concept of market basket analysis to come up with recommendations. And that you, of course, use the orders and the customer orders from the past is the primary way to understand if people buy this, are they likely to buy the other thing? Are they less likely to buy the other thing? And then they will come up with these recommendations. That is what is fed into the marketing management application. Now, as you know, this marketing management application can become dumb. And what I mean by dumb is basically this. So if I say iPad, they'll say, okay, yeah, see, the search is smart. It figured out IAPD actually means iPad. So now I click on the button for the iPad and I find that I'm getting a recommendation to buy these things in addition to the iPad, which includes this dumb item which I saw, which was the landline phone. Where did it go? It disappeared apparently. So one of the recommendations can be silly occasionally, right? A silly recommendation should not be given to the customers. So who decides that? There has to be a manual override. That's what this marketing manager is supposed to be doing, is deal with the marketing management application and actually do some human supervision as to what exactly this marketing manager and management application is going to do for the customer. They might set promotional programs about, Black Friday or this Amazon specific thing. What is it called? Some kind of a Prime Day. Right? They can decide programs on Prime Day and assign. They can adjust pricing or get recommendations as to what the pricing should be for best profitability for Amazon, and appropriately tweak the prices and have the marketing application suggest. And sometimes you will also see emails from Amazon saying customers who bought this also bought that email. If you opt into Amazon, they might send you those emails in terms of marketing messages that thank you for buying this, great, but you also may be interested in buying the other items, because that's what they really boil down to, is selling stuff to you. And we love buying, apparently most customers do. And yeah, I buy on Amazon all the time. I mean, that's the primary shopping place for me, is Amazon these days. It used to be different, but not anymore. I'm exclusively shopping on Amazon these days because of a couple of reasons, which I think you know. So I'm skipping that. Here, recommendations part, that piece which is based on the core concept of market basket analysis on a big data system of collection of all the records that you may have accumulated over the years, is what you will use in your customer scenarios to help them market and understand what else they can spend money on. That's how you can continue to be in business. So that's the three-part slide on e-commerce segment that you look at. Let's see some other pictures. Next one is, this is part number 1. So what is this one here? Yeah, this is file synchronization service. This idea is similar to what you already know very well. It's Dropbox. I'm betting that you have used Dropbox at least some point in time. If that is not correct, please tell me. So you know Dropbox, right? This application has a local client that looks like this. This is the user interface to, this is my user interface to the Dropbox service. So this is basically is an account where I'm logged in. Excuse me. This is basically my account where I'm logged in. So if you now look at this picture as a whole, there is no user as such, as a person user. There are some people showing up here, but in this picture, you don't see a person user here because there is nobody that is actually visiting the file synchronization service by themselves. You can, of course, go to Dropbox. There is a chat message. So there is a web-based interface to this thing called Dropbox.com. You can go there, but I don't know if most people use Dropbox website as such. I think most people that I know use Dropbox as a service, which means they will typically not visit this website, which means they will use this local client application that they have, and which you saw is what I'm running, is what they interface this service with. What does that mean? It means there is no person involved directly doing a DNS query. So there is no person, but instead of the person, there is person's laptop, desktop, and that laptop is running Dropbox application, and that application is doing a DNS query. And then through the query, this user's laptop is actually represented right here. And the user's iPhone or iPad or other Android devices are represented by this device. Both these applications running on the desktop or mobile devices are basically doing a DNS query and accessing the content stored in some kind of a file repository, which can be a bucket-based storage. That's what you look at when you visit the, I still don't have the code, but let me get the code. So this two-step verification code I'm waiting for from Dropbox, which should arrive here and right there. So if I log in, you see a bunch of files that I have stored in my Dropbox. You've seen it already. So there is this thing that I see, that a collection of pictures from Aurora Borealis that I saw, which is sitting in my Dropbox. So here is what I took a picture of. Nice. But what I just did is, on this device, on my laptop, I was able to access this item, Aurora Borealis, coming from the file repository. And it came straight from the some kind of a bucket location to my desktop or laptop. That's what you saw in this example that I just pulled up, a picture of this Aurora picture that you saw here. It is coming straight from some storage location. However, there are a bunch of things happening behind the scenes. You have all these files sitting for every user in some kind of a file repository in a central location. However, the benefit of Dropbox that you see as an application running here on the desktop or laptop or a mobile device is that it actually brings out local copies for you. So it synchronizes in your Finder. You can probably see, if I go to Dropbox and find out Aurora Borealis, you can get to the same picture, 9271. Our 9721 is what picture? This one? It's the same picture sitting locally. So I have this copy of the same exact picture that I took, which is in my file system, locally available. If I decide to rename that file, say 9721-Nilesh, I just renamed it. The changes will synchronize. You can see that Dropbox just synced the same changes back, and you see that this particular image is already changed. That interface that you're looking at is basically enabled through the file system synchronization that is happening between your desktop mobile devices and the bucket storing your files. The particular one that I was using was this file. So it renamed that file. So that's this portion of it. It's the simple portion of understanding this segment. Is easy to understand. The other pieces that you're doing in this picture illustration is the implementation of a file synchronization service where you are able to share your files with other people. These people, this picture is using the word file followers because what they are really doing is following a file. So this file that I just changed to a different name, I renamed it with -Nilesh. That file is something that I may want to share with these file followers. So what I can do is look at that picture and say, I want to share it. And then I can assign it to an email address, say one of you guys, say Travis. And so I can just give it to Travis and say, hey, Travis, I share it with you. So now Travis has access to that file. As simple as that. So as soon as I send the share button, what you will see is it generates a token for every item that I want to share with. And that token is stored in a token service. It also will notify Travis with an email saying, Nilesh shared this picture of Aurora with this file name, and he wants you to see it. So I just shared it. That email will be sent out from this simple email service, automated emails coming to or rather being sent to Travis, for example, where Travis will receive that email saying, I have this particular file shared with you, Nilesh has shared it. And by the way, if you want to access it, you need to access the security token before you can actually access the actual object. And so that's what this particular service will make this user do, is sign on and get access to this token. Once they have the token, they can use the token to get access to the bucket and get to the item that they need to get, which this original user authorized this particular user to get to the item that they want to. Now, from a sharing perspective, the Dropbox solution that I just showed you as an illustration is probably one of the most well-known implementations that you have already consumed and used. So here is another one, and this is open source. It is called Nextcloud. And here is another one, open source, called OwnCloud. And you can see implementations of these things, and you can create your own private cloud. You can run this open source on your machines in the cloud and generate your own Dropbox if you want it like that. And there are more such examples where you can store your data in your own location, in your own control. And there are a lot more features bundled along with these cloud products like Nextcloud and OwnCloud and things like that. But that's the core idea behind file sharing service, where basically what you're doing is allowing these users and these file follower users to share files among themselves in a secure manner by ensuring security through issuing a token for every item. That's this illustration would basically describe. This is how you would go about implementing such a solution from a file sharing and synchronization perspective. And that sync that you need to be able to do with this file follower, provided this person, Nilesh, has sent this picture of Aurora to this person, Travis. And if they gave them read and write permissions, in that case, Travis can actually send new files and modify this. And then as a consequence, Nilesh receives the updates. So those changes, you can depend and decide on whether you want to give a read-write permission or just read-only permission, or you want to revoke the permission. You can also revoke the permission by revoking the token. So you can just say, I get rid of the token, mark the token as invalid. And if the token is invalid, then any point forward from that point beyond, Travis will not be able to access the particular object because the token is invalidated. That's how you revoke access to every item that you may want to or may not want to share. You can access control specifically by using the token service that you have in place, this one. There's a question somewhere I saw. No. Okay. Next one. What is this? Okay. So this idea of grid computing is basically a lot of number crunching needed. Most of the big businesses typically uses the most typical uses involve some computation. The type of computation that you would do in a banking industry where this is what this is, basically banking and financial institutions, they want to do trading, they want to do money management activity, they want to invest and basically deal with money. And so for that to happen, you need to run a different set of algorithms. And those algorithms is what you would run in a collection of machines. They're different from your HDFS and MapReduce applications. They're not that type. They are different, meaning, let me show you some examples of what that means. So a Monte Carlo simulation is an example of what a financial institution would do. So here is Monte Carlo method. You can read about how it works, but bottom line is it predicts a estimated value. Rather, I should say, give you an example of what that means. So Monte Carlo simulation will be useful in estimating derivative prices. So let me show you a simple way to describe this is like this. So have you heard of this thing called option on a stock? I'm pretty sure you have, right? You know what a stock option is.
Yes.
However, that's the employee stock option plan. That's typically what you would see. If you are a stock trader, you would know what an option is in two different forms: a put option and a call option. You know what these things are?
They're bets.
Sorry?
They're bets. Yeah,
Yeah,
betting something's going to happen or
correct.
not.
They're a bet. Actually, I would describe. So I'll describe what these two bets are. Anything is a bet in life. So yes, they're bet. And so when you generally talk about options, and corporate employees typically believe they're talking about employee stock option plan or something like that. But options are actually two different types: put and call. And let me simplify this in the most easy to understand fashion. A call option is a coupon, and a put option is a warranty. That's the best way to understand these things. Now, what is a coupon? A coupon, and by the way, let's talk in terms of pizza. So pizza is typically $20. Today, I give you a coupon of $8. So you can buy this pizza for $12. But this coupon is valid until a period of time, say January 2018. So the coupon expires. The pizza doesn't expire. It is always available fresh every day. It's going to be available like that for a price of $20. It might change up and down a little bit. But coupon, $8, will reduce the price from 20 to 12. You know that. You understand it. That's what a call option is. And that is what a regular ESOP option is. The same thing. Same thing. Now, what does this do? This $8 value, what does it mean? Can I give you $8 and get the coupon from you? Would you sell me? I would say, yeah, you very likely take cash, $8 cash, and give me the coupon. Can I buy it from you? Yes. How about if I pay you $7 and you just had dinner and you had like no desire to have pizza because you have for the last 7 days you've been eating pizza. And so there is no desire for you to get pizza again because you're sick of pizza now. And so you have the coupon. This coupon is with you. You know it is worth $8. Now I come in and say, hey, can I buy this for $7? Would you sell it to me? Just imagine you had for the last 7 nights, you've been having pizza after pizza. You're sick of pizza now. You have the coupon. The question I have is, will you sell the coupon to me for $7? Anybody?
I would.
Yes, you would. I know you would. And I know because you had like lots of pizza and you're not in the mood of having pizza, you would rather get $7 cash and give away the piece of paper.
I wouldn't. I have until January.
Yeah. How about if I say $7.89? Would you sell me? How about $7.99? Would you sell me?
I mean, yes, I would.
Yeah, exactly. That's what I'm saying.
Cash is better than a coupon.
Yes. So the point is, the value of an option, the value of an option goes down over time, slowly. As it is closer to expiration, the value of this coupon will shrink down to 0 at the expiration date. like end of 31st of January 2018, the value of coupon at the end of business hours will be 0 because it's worthless after that, right? So the value of this coupon is declining pretty much like this. Now, why am I talking about this? That is what banks do, is they want to estimate the value of coupon. They want to estimate the value of a call option. Call option is coupon, basically. And so that's what they're doing. Now let's understand the other option also quickly. Another simple example. These are hard to understand concepts unless somebody describes it to you. And so you go read about call options and put options, and people throw mindless data at you without helping you really understand what that thing is. So call option is a coupon. You get it. I think you understand what it means. Next one is put option. Put option is warranty. And so warranty is like pizza, $20. And I have a warranty for the pizza. That means I can take the pizza, take it home, and on my dinner table. And the warranty is that this pizza will still be warm and nice by the time it arrives on the table, and then you can eat it. But the warranty kicks in if the pizza is not warm. What happens? You exercise the warranty, and then the pizza will replace your $20 back. Sorry, your pizza was not warm enough. It went cold, it went stale, and maybe along the way the driver dropped it and the delivery person did not put it on your table. So it is the problem of the company. Actually, this delivery problem is not. It has to be warm. That's a better way to think about warranty. Let's think about another example. I buy a washer and a dryer. Buy a washer and use it today. And I put it in use. This is today, and I use it for like 3 years. And I buy a 3-year warranty. Anytime during the period of this time, if the washer breaks down, what do I do with the warranty I have? Is I claim. When I claim a warranty, I can basically have the person who sold me the warranty take the washer away. So the washer, I bought it for $1,000, and I can get my $1,000 cash back. That's what a warranty essentially is. It protects the value that I hold. I buy a washer for $1,000. It should work for 3 years. You promised. If it doesn't work, I give you the washer back. You give me my $1,000 back. That's the warranty that I purchased for an extra $200. No, not $2,000, $200. So I spend extra $200. I buy a $1,000 washer. I'm going to use it for 3 years, but after 2 years, it breaks down. So I say, I claim my warranty. You take your washer away, give me my $1,000 back. I am down by only $200, but that's okay. Because it's a claim of warranty. I'm basically avoiding my risk of that washer going bad. And that is exactly what a put option does, is you have a stock price of, say, something like the Apple stock, $166, and you buy a put on the Apple stock, which is basically like a warranty purchase. And you're basically saying that for the next so many days or months or years or things of some period of time, some time period, I want to make sure that this price of this Apple stock should not go below 150. And if it goes below 150, too bad. I don't care. I just get $150 cash. I have this stock. I bought it for $166 and I pay $10 more. This is the put option that I buy. And as a consequence, this shrinkage that might happen in the stock might go down, and I am risk averse. So I want to protect my money at this level. And so that is what I'm going to buy, spend extra $10. So I'm effectively down to 156 as a consequence, but at least I have a protection below 150. So if something really goes bad, goes south, I am protected at 150. That's what a put option does. And so to value assess the warranty cover, or to value assess the option of a put, meaning to assess the value of a put option, you need to do calculations. These values go down pretty much like this. To calculate at what point, how much should I pay for a put option? How much should I sell a put option for? How much should I pay for a coupon? And how much should I actually spend to buy a coupon? Is a calculation done using the Monte Carlo simulation. This one. And you can read more about it, but I just gave you the idea. So that is what is going on under the hood in this picture, is they are doing grid computing, which is needed here to assess what should be the price that I want to pay. So let me show you some APL options to help you understand. The chain of options is looking like here. So the option chain for Apple stock is $166, up $3 some change. And if I set an expiration time, where is this is not easy to read. For a person who is new, it's not easy to read. So yeah, bottom line is it is helping you understand the valuation of a put and a call option. And that requires a lot of modeling and simulation mathematics, which is what typically companies will do, banking companies and financial companies will do in a grid like this. So this is the grid engine. What it requires is a lot of data. Sometimes you need to do batch processing, for which they have EMR, Hadoop cluster, which will do a separate type of computation in a separate cluster. And what you are really looking at is gathering data that you have collected from historical data models for any kind of transaction activity that you may have in a banking institution. You will apply this kind of a grid computing architecture to solve your industry's problems. In the context of what I just described to you, is the underlying math needed requires a separate setup as opposed to an HDFS setup or a MapReduce setup like here. It requires a grid computing setup, which operates basically the same way. And you can run it in your data center, you can run it in the cloud. And that's what they're trying to illustrate here in the corporate data center, as well as in the context of a cloud and a connection between the two. And here are your internal bank employees operating on your need for the business. Okay, let's go to the next one. Here is fault tolerant and high availability. That means you are a big company. You have a need to have your machines and equipment running all the time, no matter what. So what do? You basically go at least double. So you spend your money on one setup in one availability zone, and you spend the same exact thing again on another availability zone. And you run these things simultaneously all the time. And if something goes bad in one availability zone, no problem. You just fail over. That's the scenario that you have seen. I think we have played some examples of this in a load balance setup in two different availability zones, multi-AZ database, multi-AZ applications. You have seen, we have done exercises like this. That's what they're describing here as fault tolerant high availability. And so in case of a disaster, let's see what they're describing in case of a disaster. When disaster happens, you want to let this end user not even be aware of something went wrong. They shouldn't even be made aware of the fact that something actually went bad. So here, imagine if this unit goes bad. It was active. So when it goes bad, you basically have this standby machine, which is this one, kick in. So the user is automatically redirected to a standby application, which is already live and up and running. While that standby gets activated, your users are still, not aware of the fact that there is a disaster happened, and your machine, this one is dead. So the active machine is dead, and now the standby machine is now active. So this is not standby anymore, but now you have a weak point. So what you do is you create a replacement, and this will replace your old active machine. And this is your active machine. As it activates, you will rename the replacement machine as your standby machine once it gets ready. So when this gets ready, this is your active, this is your standby, and they'll both run simultaneously. If something goes wrong again, you just replace the broken thing with another one, and these users will never become aware of the fact that one of the machines die. And on the back end, you have a snapshot of your disks on both ends. You're copying those snapshots, storing them locally, or storing them in the buckets in a fault-tolerant solution set. And that's how you will enable a high availability, fault-tolerant design from a usage perspective. Let's see what else we have in the picture here. Gaming. I'm not sure how much are you interested in gaming, but this is the scenario that you can think of in any kind of a game, mygame.com, some game website where these players are logging onto using the DNS resolution to this mygame website, and they are interacting with the game. Game interaction, as you may have seen already if you play games, is basically a method of exchanging useful information about the player's state. What do they have on their screens, and where they are, whether they are fighting somebody or God knows what they're doing. I don't even play games, so I cannot describe these things nicely. But I can maybe attempt. So pardon my game ignorance. I'm making stuff up right now. As a game player, you might, let's say you're playing some kind of a shooting game. So you have some bad guys there and a bad guy there, and you pick up your gun, and you have like 10 guns. So you pick a gun, and then you walk, and then you find some object it's called points, or some kind of gold that you find. You pick it up. So that geographic representation of your gameplay at a point where you have to go, let's say on a map in the game, you walk from here to here to here, and then you find gold. And that gold discovery is actually represented in form of a JSON file that is sent to your browser or to your game console from the back end. And that is what you're looking at here, JSON interaction. And that JSON representation will have saying, if you go walk 10 steps this direction and then 5 steps this direction, you will find gold. Okay. So I found gold because that gold representation of JSON was actually pushed out to my browser from the back end as I was playing the game in an interactive fashion. So this game needs to, the backend service that you're running on a game service of some kind of game.com needs to be aware of what each and every player is doing at a given time. And that's what these web servers will basically be responsible for, is exchanging information in form of bits and pieces of JSON exchanged between the game that is running on the game consoles here for these players, and what they are interacting with, how they are interacting with, and based on that, the game will send interactions, and the backend website will also respond back with corresponding appropriate actions for the gameplay to be successful. And by successful, meaning pleasurable, enjoyable for the player. And that's what a player would expect from the game. But on the back end, you're keeping track of what these users are, how much they have played, what levels they have passed, how many bad people they have shot, and how many guns they have lost, and how much gold they have found, and all those things that happen in games typically. And pardon my description, but it's kind of silly because I never played games apart from really old ones. So I have seen people play games. My son plays games, but not me. So that's what gameplay basically is, an exchange of JSONs between the playing console. So you have your Game Boy in your hand and Nintendo on the backside. Nintendo.com. Why just Game Boy? We should talk about better games like Pokemon Go, for example. So the same thing happens in Pokemon Go also, where you have an iPhone or an Android phone in your hand. And on the back end, there is Kubernetes running Niantic application, which is what drives the Pokemon Go game. The same thing applies in case of Pokemon Go. You're doing the same thing. You're like holding your phone in your hand and you're walking around like crazy, looking for objects. And those objects are basically geo-representations of various Pokemon. I used to be a Pokedad. My wife used to be Pokemom when my son was young, but I've forgotten the whole thing now. So these characters called Pokemon characters will appear at various places, and that appearance is basically represented on your iPhone device based on geometrics, or rather latitude, longitude representation on a map, where they will actively place Pikachu in a given spot. And that location, let me show you something. I think I might have it. So let's go to maps.google.com. And so here in this particular location, I know, let me see where am I? Locate me. Yeah, come on, show me where am I?
Hey, Nilesh, do they know your orientation as well, so you can see where the thing is? I was always wondering that.
Yes, indeed.
Where am I looking? Right?
I know, exactly. Let me show you exactly how they look. I don't know why my maps would not open, but let's see, this Maps app should be able to detect where am I. And so my map location. So here is me. So they will, first of all, GPS is available. Devices today have multiple ways of measuring location. So let's see, Chrome, and you have accelerometer and gyroscope. And so you have these devices built into your phones. One of them is accelerometer, which basically measures how quickly or moving, how rapidly you move the device in your hand. Are you like shaking it or rotating it like this? That is controlled by another metric called gyroscope. And so these devices are built into your phones. So this gyroscope is also built in, which basically controls the game called Jenga. If you have played that game, I don't know. But this game, it's a block game that you have played in physical object. This Jenga game, you can buy it on Target. So that same game is available in the iPhone also. And what you can do is actually hold the phone and walk around the Jenga thing and physically place the bricks in a fashion that it doesn't actually fall the whole thing down. So that as you hold the phone and roam around and turn around like this, the gyroscope inside the phone will know your orientation, your location, and the motion that you're making, and will automatically transition. You can see a similar example of this same thing if you open Facebook app and you look at a 3D picture somebody posted, and you hold your phone and go like this. You will see that the picture changes. I hope you're looking at my hand. And that's what you may have seen already. That orientation change and the gyroscope change actually is able to rotate the 3D picture. Now back in our JSON exchanges that you're looking at in a gameplay, if I am sitting here, which is my home is, if I know that in our area, where is that location? There is some spot here. So in this location where there are lots of shops and Safeway and Starbucks, they deliberately place interesting so-called rare Pokemon characters in those locations, specifically in the Starbucks locations, because Starbucks is paying Niantic to attract Pokemon Go players.
Yep, but that's where mom and dad go while you're looking at your Pokemon.
That's right. So that's the idea. So it'll exchange the information of geolocation of this Starbucks and this other places. Like sometimes you can actually run promotions of other activities. If you want to get, say, if you want to eat Thai food, then this Land Pony Thai cuisine can actually place Pokemon characters in the game, so that people who seem to like Pikachu also like Thai food. I'm just making it up. Might show up in that restaurant. So the restaurant can actually pay money to Niantic and have them place rare Pokemon in that location so that people will actually come and hover around this location. And that's how you can get physical pass-through traffic, like get people to attend your location, like get people to visit you. Otherwise, it's hard to run a business in an isolated location if nobody's actually coming over there. So that interaction is, at the end of the day, is happening between a back-end server and the player's device in their hand by exchanging of relevant information between what the users are doing. And then you can extend this, I think in case of virtual reality, like augmented reality, like this Pokemon Go game does, it communicates back to the web server how the person is holding the phone, what GPS location is, whether they're pointing north or south or some other direction, how the inclination of the phone is, and all that metric is also sent. Along with that, they will respond back with appropriate data about where the particular Pikachu character is. And so you can see it as you watch it through the phone. And that's augmentation of a physical reality, is augmented reality, is what is represented through that game, which requires such a system. At least this is what Amazon thinks that you will implement. And in case of a backend that runs an application, now here is a auto-scaling simple representation, but I know that Niantic has actually deployed a Kubernetes cluster, which can take shape of an auto-scaling cluster, but doesn't have to be exactly like what these guys describe. These are just helpful diagrams for us to discuss these things in terms of understanding what would it take to implement a given type of application in the cloud context. Now here, if you go further, these game files that you get download, like sometimes you download something which is going to extend the capabilities of your game. That download needs to come from some cloud delivery network, content delivery network, such as the CloudFront CDN in this example. That will come down again to the game device or to the browser or to the Game Boy or the Pokemon Go app, again from the CDN, which is coming originally from some kind of a location, centrally stored location. Sometimes these games have this idea of what is called a save state. And a save state is basically, I don't know what the word is game players use. I think the word is just save. I saved my game and I can resume from that point onwards. That's what gamers call it, save. And so I call it save state because you're saving the state of the user, saving the state of the player. And that save state is saved here, some kind of also in the same bucket. You will keep track of where the user last saved it, and that application that you have running here in this cluster will basically keep track for every single user what that current save state is. And when the user wants to resume from that state, you want to keep track of that and send them back to the same point in time where they began or where they last paused, so that they continue their gameplay experience. Otherwise, you have a frustrated game player if you reset the game all the way to the beginning of the game, which is bad. And people will just hate the game if you do it like that. So this game save, or saving the state of the game, is also important. And you save it in a bucket through your application and store the information about the save in a database so that you can resume it. Extending this idea that you have is that you are now collecting a lot of data in your database about who's playing, what locations are they playing, what games are, what activities are popular, where people seem to go, where people seem to want to go and want to avoid. You can gather that statistic. And as a consequence, I think the last time I remember, somebody in the previous boot camp was telling me that people in Boeing company in the Everett factory, Pokemon characters were showing up inside the factory. And so factory workers were actually not working, but instead hunting down these Pokemons. And that is a unfortunate effect that you have, which is what I don't think Boeing wanted Pokemon characters, but apparently they showed up by either accident or by bad design or by evil design. I don't know what. But somebody told me that Boeing had to call Niantic to remove those Pokemon characters from their geo-representation inside the factory so that people in the company can actually spend time working. I don't know how much of this is to what extent, because I have not seen it, but that's what I heard is an implication of. Have you seen such a thing?
Well, we got a memo stating that we weren't allowed to play Pokemon on any Boeing facility, so I think it was a big problem.
I know.
Extortion. We're going to do this to companies until they pay us to not do it. That sounds great.
Yeah. So yeah, that is a problem if you think about it. So if you think about like on a national scale, here is our country, and in Washington D.C. there are these historical places and a bunch of national archives and beautiful places to go and visit from a history perspective. And what people noticed is that lots of people playing Pokemon as visitors are watching those. So there was a problem even in Washington D.C. where they had to remove Pokemons away from national monuments, which was a case, I think, in news in the last time. So from a geo perspective globally, you will see the same thing, and is the data that Niantic has collected over the time. And it used to be a top-notch game, number one, not number one anymore, but still useful. People still seem to be playing it. Sometimes I see them. And so the evolution of this on the backside that you look at here is basically boils down to data mining. You have collected a lot of data and you want to analyze behavior, analyze whatever people have done with your game so that you can find out new ways of improving upon user experience and new ways of making money. And the money is hidden in your data these days. So most people will want to have data about what you are doing because they believe that they can analyze it. And once they analyze, they can come up with something interesting that you can actually do, which is what data analysis boils down to. And so they use some cluster again to do the data analysis part in gaming, online gaming as an example.
Now, I have a question.
Yes.
That I've been curious about. My son, he plays with a friend in England and one in Japan. How do you think that they solve the latency issue? Because you figure, let's say you had this in Oregon, this setup, the people might be at a disadvantage if you're doing a shooter game or something like that. So somehow they have to make up for that. I was just wondering if you had a opinion on that.
Right. So I'll describe the idea of latency. The latency is, let me describe first what latency is. And I think most of us understand it very, very well. It's the time it takes for something to happen before I put a trigger at this point, pull the trigger, and then something happens after some time. The delay in between when I pull the trigger and when the thing actually happens is the latency. Now, latency comes down from a variety of factors. It is one factor. The big factor is distance. The second factor is how quickly your machines are responding. So you have a machine here, which is your game device in your hand, and your other machine here on the other end, so the back-end server. Sometimes that's a game. Sometimes it's a P2P play. A P2P play is where two people playing together. And there is not much of a back-end interaction. So in that case, the interaction is between this person who pulls the trigger and this other person who pulls the trigger. So P1 and P2 playing together. That's P2P, and the distance between them is also a factor. The second factor, which is also relevant, is the handheld device that these guys have. So you have P1 uses this device and P2 uses another device. That if the devices are slower, like if it's a PC game and the PC is slower, you have a problem. So the speed of the PC is the second issue, speed of the device. That's the second problem.
I actually know a little bit about this topic as far as it goes with games.
Go ahead, describe, please.
In particular, there's a couple of common methods that they will use, especially in first-person shooters. Some of them, for example, do all of the calculations of who shot when and whether they hit someone on the server side. And then others trust the client to make that determination. And the games that use clients to make that determination, the servers will almost always have this rule where they will kick you off if your latency is over, say, 200 milliseconds.
Yes, because they don't want the other people's to suffer because of you. They're waiting for you to respond. And if you're late, if you're slow, if your machines are slow, if your network is slow, you don't belong you're basically deteriorating experience for other people. So they kick you out. Right? Yep. And that is typically observed when you have in a home setup, when you have a lot of download activity happening and your internet is throttling, the game player in the home will complain. I see this occasionally when I'm running a new virtual machine image and I run this Resilio sync all the time, and I have a new workstation image. As soon as I upload a new OVA there, and if my son happens to be here, he will complain immediately, because that's what he gets impacted immediately. Like, okay, I'm playing a game and you are now doing what? And I tell him, yeah, fine.
Who gets priority?
It is the children's home that we live in, so that's understood. Yeah, I think that's how the world is. So we live in our children's homes. Okay, so latency topic, there's one more thing, which is speed of the device and speed of your graphics card. So if you have a PC gamer or some kind of a display gamer, then the graphics card needs to be also more memory and low latency memory, so you can actually refresh the screen faster. That's another thing. The fourth thing that is relevant is your network latency, the ping latency between, which is basically the first factor here, distance, which is a major aspect of how low latency your network connectivity is. There is other thing that comes down to latency, which is not strictly latency, is the idea of jitter, which let's read it. I think it's better to read the definition of what jitter is. So jitter is, okay, here's a good definition. Is the deviation from true periodicity of a presumably periodic signal. That doesn't communicate much, but that's what it means. So deviation from true periodicity of a presumably periodic signal. So it means if something is going to happen every second, and if it doesn't happen every second, but instead it happens erratically, like it happens here and happens one sooner and then later and then more late and then sooner again. So that is what you will see in the same span of time. You have these activities happening 1, 2, 3, and 4, and they happened 1, 2, 3, and 4. They happened like this. And so that is not equidistant. These guys are not equidistant. These guys are apparently. And so that is the idea of jitter. When you have a jitter conversation between 2 points talking to each other, 2 machines talking to each other, the other machine expects a activity happen every second, at least expectations point of view, but it seems to be happening erratically, like here and here and here and one other one here. So as a consequence of this, in spoken conversations, you may have seen this occasionally when I speak. And if you did not see, which is nice, but if you see this, if I speak like this, suddenly slow down, I speak faster. That might happen, but I think that issue has been resolved. It used to be in older voice over IP systems that this used to be a big problem, where the spoken conversations or interactions which were expected to be at a certain periodicity did not actually be sticking to the periodicity expected, which also causes trouble in gameplay, because you expect that a particular action is happening in a multi-person first-person shooter game. You pull the trigger and the bullet doesn't fire, or the bad person on the screen seems to be doing something in a completely different perspective. And that is what you run into when you have not just bad latency, but a very jittery internet, where you cannot really predictably send a packet and expect the packet to land on the other side at a predictable duration of time after it was sent. If that predictability is missing, the overall gameplay becomes erratic. You can see that in traffic examples as you drive down to a highway and you suddenly see a lot of traffic jam. The reason of traffic jam is not that there is too much traffic, but there is jitter in the speeds of cars traveling on the road. Some is going at 30, some is going at 40, and others are going suddenly stopping for a second and then going at 60. Yeah, the whole thing slows down, and you might see that it is traffic jam, but there is actually no jam. It's just jitter in the speeds of cars on the road that might cause a blockage. Same thing happens in networks and gameplays and any kind of internet communication. So that was about gaming that we discussed briefly. Let's move to the next one. What is this? Yeah, so this is an example implementation of what the way I can apply this is when you have a variety of equipment generating data. Equipment generating data is what this illustration is. You have seen or may have seen or heard of this thing called SCADA. If you haven't, let's go read it. So it's supervisory command and supervisory control and data acquisition. So that's what SCADA is, and what it really does. Think of it simply as a method of collecting metrics of a variety of different types. And so a simple practical application would be, I have this, in fact, in our area in Washington, we have this pipeline called Williams pipeline. It goes from, in our state, something like, across from Vancouver down south, something like that. It goes like this somewhere through our area. So there's a pipe that goes. It's a big pipe. It provides gas to all of us, almost all of us. And that gas pipe is basically a big giant pipe, underground pipe. It flows liquefied gas, natural gas, LNG, or whatever gas we cook at our homes and heat, that same gas. So when this gas is flowing in our neighborhood, we need to be aware of the fact that there are not going to be any disaster, right? That's the primary concern of civilian authorities. So they want to measure a lot of characteristic about this gas flow as it flows through the pipe. What do they want to measure? The speed, the turbulence, the temperature, the pressure. And they want to do this, and there are a bunch more metrics, by the way, that I don't even understand some of them. So these metrics they will collect at every geolocation after so many meters, or rather, what's the metric we use in this country? Yard? Is it yard? Probably yard.
Mile, feet.
No, they wouldn't. Yeah, it's like a meter size. So every so many meters, they will measure these metrics and collect them over every single hour. They will collect those metrics hourly, sometimes. Hourly metrics of speed, pressure, turbulence, temperature, and gather all that detail across every so many meters across the entire length of the pipe throughout the state, and collect all that detailed data, something like here. So that is one example where I can apply this, where you have some kind of a SCADA system collecting data about a bunch of different, what I call, there's a word for it. These days we call it IoT.
You call it telemetry?
Yeah, telemetry data, IoT data, bunch of different measurements coming in from a variety of sources. So this was oil and gas was just one example. Another example would be, as you know, we have this car called Tesla, which has about 16 or so cameras outside, and it on the car on the outside there are lots of cameras on all the sides, and these cameras are continuously capturing data that you see on the road. So these are basically eyes, and that data needs to be stored somewhere and processed. Now, as a matter of fact, the entire video stream from all these 16 or so video cameras cannot be sent to the cloud. It is impossible. There is not enough bandwidth available in the car, although the car has internet. The bandwidth available is like a 4G LTE. So it is not enough to send so many camera feeds out to the internet. So it is not practically possible to send all the data. So they create proxy of the same video by looking at, let me show you some examples of Tesla. What does Tesla see? So in this video, you see some illustrations on the right half of the screen. So watch the right half. What you watched on the right half of the video portion is basically a representation of the video, not the actual video itself. So if you now watch it carefully again, you have this image that is represented in terms of left rearward vehicle camera is showing you some object right there in the green section. There is this red line showing some kind of a boundary condition. There are these green objects showing in the right rearward vehicle camera. So what you're looking at is these rectangular objects and the intensity of the color. That information is what is actually transmitted out to a central location from Tesla's perspective. And that's what Tesla will gather detail about, where these cars are, what are they looking at, how are they driving, where they're heading, where they're coming from, how much can they go, how much battery left, and all that collection of statistics is what will need to be collected in some central system, not the entire video, but some representation of some sorts for any given business. And again, we are talking about huge data sets. So you're collecting them, multiple pipes of data sent to you in form of, another example would be Windows and Mac telemetry. So these units of computers that we have in our hand, and iOS and Androids and all of them collect lots of telemetry based on user content, user consent. You have to agree to the telemetry being collected. And you may see notices in Windows and Mac. Sometimes you'll say, do you want to share the data with Apple, or do you want to share the data with Microsoft? In that case, if you say yes, then that data is also sent to Microsoft or Apple, and that will send performance of your computer, what activities are happening in an aggregated anonymous fashion, and that data gets collected and stored and processed. So it's a simple representation, but the concept is applicable to almost every industry where you have a lot of data coming in from your endpoints of users or machines or equipment or applications that are deployed out in the wild, and they are generating data and users are consenting to share the data with you. So you're collecting that, but then what do you do with it? The doing part is the hard part. You get the data and you keep it here, that's great, but what do I do now? So you read from it and try to make sense out of it. For example, a sense of something would be that if I find that people open this Notability app and it crashes, so then they open the Notability app again and it crashes again. And it is happening across the board. Not that it's happening, but I'm just picking up an example. So the telemetry of this Notability app getting crashed over and over and over again for not just this user, but apparently it seems to be happening across all the users. I need to get alerted. My developers of this application for Notability need to be notified quickly, because I don't have to wait for users to call me to tell me that my app is dying, but I can always automatically find out based on metrics that I collect and send appropriate action to the developer to have them fix and send an upload to a new version that doesn't have the break, and we sent it out. Another example of the same thing will be in my previous company, previous company, I used to be a company at EMC. EMC makes discs, and those discs are, a $1 million box containing 600 discs. Those days, it used to be magnetic disc those days. So small 600 or so disks sitting in one big giant refrigerator or refrigerator sized machine, sold at $1 million price. And the idea behind that box, called EMC Symmetrix, was that you can guarantee that these disks that you have, 600 of them, will continue to perform no matter what. And that guarantee was provided by EMC because of a metric that they used to collect from the box and centrally store in some kind of a similar structure, and look at the data coming from the disks itself to understand which of these disks is going to fail. And so if they notice that a particular disk is reporting a problem here, that disk, they will dispatch a person and have the person go in there, replace the faulty disk, and put in a new disk in its place, the good one, and then go back in doing their thing. And the disk system that you have in that company's deployment, and this is what banks used to use, and they still use, even your companies use, Boeing and Microsoft, both of them, I think, still use EMC Symmetrix storage system as a high-end storage for your applications that are critical for your company. And so that scenario is again possible by collection of metrics from a variety of scenarios. So here is another one, IBM Watson. You may have seen some examples of advertisements coming from Watson. Say, where is the ad? I don't know, I saw it recently, but IBM Watson has put in similar kind of methods in terms of understanding behavior of the products that they sell and get them to proactively fix a problem that they might have. Same thing Netflix also does. They collect metrics, all of them, for every user behavior of which movie they're watching, how much they are watching, how much or what segments of a movie they are watching over and over. And based on that metric, they will collect and send that information back to the studios, to Hollywood, to Disney, for example, and have them be aware of the fact that a particular segment of movie or those kind of movies run better than the others. People seem to watch these. People seem to binge watch those types and not these types. And that data is useful. And that is the evolution that you're looking at in terms of just collecting data to analyze that in a fashion that you can make sense out of it. That requires, of course, domain-specific knowledge of a given domain in which you are dealing with. And that is, of course, an interesting evolution that you're looking at in the industry as such today. So next one is this idea, log analysis, which is basically everything that you run, every application that you run in some computer will generate some logs, as simply as here. So if you go to the, you've seen logs. I'm just showing you some examples. See if I can pull up something. And so if I go to var log, I see the logs. They are here. And if I open up an interesting log, what you will see is that somebody is, let's see if I can, so somebody is getting banned. So see that log entry called ban. Some IP address got banned from connecting through SSH. So this is just a log. I see some info, ban notice, another ban, unban. So it was incorrect. So it removed that. And another ban. So these are random people attempting to connect to the computer, the Cloud Genius servers. Don't know why, but they are attempting, and this software is banning them and putting a log entry for me to investigate. These are logs that I accumulate, and this is just the fail to ban log. There are a bunch of more logs, and some of them are not relevant because I am running my services in containers. So there are more logs. For example, here is another new application that I have just installed. So there are logs for that. And of course, these are access logs, most of them. And so you can see that there is this data pattern available. It's kind of repetitive in this example, but the idea is that you have logs and you need to analyze them. And the log analysis becomes really, really useful to keep your applications healthy and make sure that your applications don't have any bugs or issues that you can actually capture without having the users report back to you. So if you have visitors visiting your sites and you have some web servers, you will eventually have these logs that I just showed you. I showed you example of 2 places where I collect logs. One of them was the var log folder, and the other one was Docker logs that Docker generates on an application by application basis. So I have these logs coming in. These are log files. What do I do with them? I should put them in a bucket. First thing, just save it. And now that I have these logs, I need to make sense out of it. Sense as in what? Same thing. Hadoop cluster. And then you analyze them and you make sense out of them. And you put that sense in a separate database. This is not your Hadoop cluster. It's a regular database, RDS, like a Oracle database or MySQL database or some other regular SQL database, SQL database that will help the person, this analyst, understand and make sense out of the data stored in a regular RDS type database or relational database, so that they can make queries and get questions answered based on what happened when something went wrong, or what happened when this particular server was running hot or 100% activity, or fully loaded, or less RAM, or running out of RAM, or any kind of issue that you're dealing in terms of server logs. In terms of application specific logs, you can actually detect those patterns through collection of logs that you store and process and make sense so that you can analyze them at a human level. Now, this was the log analysis display. There are open source tools that will help you analyze these logs like this. One of them, which is very popular these days, is called Elk Stack. So ELK are 3 different components. E stands for Elasticsearch. L stands for, let me open them up directly. Elasticsearch is one, which is this software called elastic.co. And the second software is called Logstash, which is another open source product, and they bought it. So it is now a part of Elastic. This used to be open. It used to be a separate product called Logstash, which is also open source. And the third product is called Kibana. Kibana is now a part of Elasticco, but it used to be a separate product, open source. And these 3 things together constitute a way to search the logs using Elasticsearch, a way to analyze the logs to help us understand what this thing means. I mean, this whole thing. It's just logs and logs of data, but what do I do with it? How do I make sense out of it? So for that, there is this product called Logstash, which is basically on GitHub, Logstash. It's easier to find it here and easier to understand because you can actually relate to the picture. Is the Logstash, which is what that product is. And this product actually streamlines a variety of different types of logs. It will make sense out of these patterns that you will see for the worker machine here running at this internal IP address at this date and time, got some AJAX call from this site. Used by the user was running Mozilla browser and Firefox version 56. Fine. So you have the date and time entry. So as a person, you can read one log, but that doesn't help you because there are millions and millions of log entries. And so it doesn't, this product will sanitize that for you. And then Kibana helps you in reading and visualizing in terms of simple graphs and charts. So that is what this Elk Stack is. There is a Docker image for Elk Stack. You can stand up on with one command. There should be a Docker image You should play with it if you're interested. Docker, Elk. And you can just click this image and deploy it in Docker. Just one command should bring it up, pretty much like here. This Docker compose up should do it. That's it, one command. Bring up the whole stack ready for you. And it will, you have to feed it with, what's it called? Logs. You give it logs and it'll help you understand it'll analyze those logs and give you back visual representations using these 3 tools: Elasticsearch, Logstash, and Kibana. If you have interested in playing in that direction, here is a link for you. I think we ran out of time. So I will, I think we've covered most of it probably. So log analysis, what's the next one after that? Media. I think we discussed a portion of media already there are a couple more. So we'll discuss the rest next time. I don't want to hold you up beyond the scheduled time. And what I would like to do now is to stop recording.